Assistant Award from North Carolina State University. So very good morning, Amit, and nice to have you in this session. Please, Amit.
Thank you, Ranbir, for introduction. Am I audible to everyone? So if there are any issues, please let me know. Okay. So Ranbir, can I start?
Yeah, just one notification. So since participants are large, we have not allowed to interact through audio. So if they have some question, they will be posting either through chat or question answer. So in between, I will try to, if there is question, I will try to interrupt you, and or at the end of the session, we will take the questions.
Okay, sure. Or I'll check in between. Okay. So a very good morning to all of the attendees. And thanks to Ranbir for giving me this opportunity to deliver a talk in this workshop. So the topic for my talk is detection of harmful speech in social media. So if you just look at the title slide, it tells you examples of various harmful speeches. Okay. And if you're using social media, you must have seen these kinds of posts in different contexts at different places. And of course, these kinds of posts are to some extent irritating or bit more, they can be harmful, and they can have various real world implication in terms of say mental issues or even physical threat and leading to large scale violence and other such things. Okay, so harmful speech is an important problem in social media. So let's see what we can do about it. Okay, so first of all, what is harmful speech? That's a very controversial topic. So if you are following the news currently, you must be aware about the recent article published by Wall Street Journal about what is the strategy of Facebook about handling hate speech in India. So I won't go into the right or wrong about that article, because essentially I don't have the information and I'm not an expert in that area. So regardless whether the article by Wall Street Journal is right or wrong, the important point to know is that it has attracted significant attention from various stakeholders in the society. So all the mainstream news media, television channels, newspapers, various political parties, various civil society groups, all of them, they are sort of importance attention to that particular article. And today morning only Facebook has come up with a clarification on their side. So let's not get into who is right or wrong, but important point is anything about hate speech garners significant attention. Okay. So second thing is that you often see on social media is misinformation. It's the information which is deliberately spread on media, which is not true. So a few months back, there was a tweet by Donald Trump Jr. He's son of American President Donald Trump, and he argued about the benefits of a particular medicine called hydroxychloroquine in the context of COVID-19 outbreak. And then Twitter sort of punished him spreading the misinformation. His account was downgraded for a certain number of hours and so on. And again, that generated a significant controversy. And very recently, just few days ago in India, a person was charged for spreading rumor on social media about the death of Telangana Chief Minister KCR. So harmful speech in various forms is there on social media, but that really comes up is who gets to decide what is harmful. So something might be hate speech for me, but it might not be hate speech for you. Something I might think is extremely aggressive, extremely harmful, obnoxious, and something that should be avoided, but you might think that, oh, it is free speech and it should be allowed. So I have similar experience working on a related of spam filtering. So if you use emails regularly, you must have noticed that almost every email provider will have a separate spam folder. And some of the emails that come to you, they land up in the spam folder instead of your inbox. Okay? But there is no objective definition about what is spam, which email should be classified as spam. No sort of agreed upon standard about that. So each and every service provider goes about building the spam filter in their own way. Okay? So they might use multiple clues such as, oh, what is the frequency of this email? What is the content of the email? Or does it have subject or not? What are the spelling mistakes? And so there is a long list of features that a service provider used to look at least when I was doing it in 2010. And now I'm sure that by 2020, they must have shifted to deep learning based methods. But important point to know is that we in computer science deal with problems even when we don't have a gold standard or objective definition available. In spam filtering for last 20, 25 years without having a standard agreed upon definition of what is spam. And that's why I think it is still possible to do the harmful speech detection on social media, even if controversial topic, even if all of us do not agree upon what exactly is harmful speech. And of course, people will argue that there should be no boundary on free speech. People should have liberty to express themselves. Company which provides a social media platform has right to suppress certain voices. So all those are pretty serious legal and ethical issues, and they are beyond the scope of this talk. And I have no expertise talking about those issues. I don't even have education on those issues. So I won't delve into those aspects of harmful speech on social media, but I will concentrate only on the computer science perspective because that's what I know. So even if it's a very wide topic, we are going to address only the computer science perspective. Okay? So that's the goal for today's talk. Okay? So when we want to talk about harmful speech on social media, let's be clear what we are talking about. Okay? So I tried to search for the definition of media. So at least the Oxford Dictionary has the main ways that large number of people receive information and entertainment, that is television, radio, newspapers, and internet. Uh, so media is an extremely effective tool for business, political parties, and other organizations to project their point of view. So whenever you see any particular, say, entertainment channel, you would be bombarded with various advertisements, and they would tell you to buy something or do something. Okay. Uh, so if you look at the variety of traditional media, such as television, radio, newspapers, the the common aspect about them is that they are one-way communication. So a particular author will write the book, and the reader is just supposed to read. The reporters would gather the news and write for you, and then you're supposed to read the news. The editors would edit the periodicals and publish them, and then you are supposed to read them. Or you can switch on the radio, and whatever the radio jockey or radio station tells you, you have to listen to them. If you switch to television, well, whatever it's shown on your screen, you have to see that. Okay. Or if you go to the news websites, you have to go and read the news. So all the traditional media is about one-way communication. There is a select few people who generate, who would filter the content. So these are the select few people who decide what topics to address, how to address, and then a large part of the population is supposed to consume it. That's the way traditional media is designed. And then comes the social media. Okay. So Oxford Dictionary defines social media as websites and applications that enable users to create and share content or social networking. So when social media began towards the beginning of 21st century, well, people expected that it would be a platform for individuals to express their point of view. Because in traditional media, the large part of the population really did not have any say in deciding what is said in the media, what is communicated in media. So now that everybody has account on a social media platform and everybody can post their views, it was seen as a nice democratization of media. But if you trace the history of social media in past 20 years, it has now evolved just like the traditional media. And now it has evolved as extremely effective tool for businesses, political party, and other organizations to project their point of view. So if you go on Facebook, there would be book pages. If you go on Twitter, there would be sponsored accounts and so on. Okay. But the distinguishing factor about social media is that it's a two-way communication. So if somebody posts their video on YouTube, well, the viewers can give comments, they can give likes, they can give shares, and so on. Or if somebody tweets on Twitter, that tweet can be retweeted with comments, it can be replied to. If somebody makes a post on Facebook, it can receive various types of reactions. If you write article on Wikipedia, others can come and update that article. There is a lot of give and take in terms of communication in social media, and that's where the social media is quite different from the traditional media. And third part we have to define is what is harmful speech. Okay, so harmful speech can come in various forms. Okay, so here I'm focusing on three types. First is the hate speech, or some sort of bullying. So it is defined as speech or writing that attacks or threatens a particular group of people. So this group can be based on anything such as race, religion, orientation, political orientation, or even the physical looks of the body. So tall people, short people, fat people, thin people, and so on. The other form of harmful speech that you would, so if you remember the title slide, the first line in the title slide was a hate speech. It said that, oh, certain types of people are not worthy of attending online seminar. So it is completely showing hate towards a set of people. The second line was the example of misinformation, where false or inaccurate information is deliberately spread to create chaos. Okay, so second line was example of the misinformation, where I said that, oh, information security is a hoax spread by large corporation. And third type of harmful speech is the rumor. So it is some sort of story or report which is uncertain or doubtful, but it is still circulating around. So it is a bit different from the misinformation. When you circulate misinformation, you have a very clear objective to spread or deceive people. But when rumors are spread, people are not really sure if it is true or false. They are spreading it. So saying that if you share this article to 10 people, you would get a good news, false in the rumor. And then there are many other types of harmful speeches. For example, there is impersonation, where you go on social media and you try to impersonate other person. So there are many such accounts, especially for the politicians and industrialists, where people are just creating the account in their name and they try to impersonate them. There is something called stalking, where a person follows some other person everywhere on the social media. So they might not write anything hateful. They might not write anything aggressive, but they are just following you everywhere, your every activity. So they would go and like your every photo. They would go and comment on your every post, and so on. Okay. So that is also a sort of harmful speech. So there is a wide variety of harmful speech on social media. But we'll restrict to only a small subset of that, because we have quite limited time. Okay. So out of all this variety and introduction, I will talk about a specific work that we have done on detecting cyberbullying across multiple social media platforms using deep learning. So cyberbullying, uh, a sub or a special form of hate speech. So before we go into that, there is another work that we are currently doing, is we are analyzing the use of social media by national armies. So like, has its own Twitter account. US Army has, and many armies across the globe have their social media accounts across these platforms. And not just armies, even the paramilitary forces like CRPF and other such forces, they also have their social media accounts. And currently, we are analyzing how they use the social media and what are the trends, what are the topics, how do they get more attention, and things like that. Okay, but for today's talk, I'll focus on the first topic, which is the cyberbullying detection across multimedia platforms. Okay, so let's go there. So till this point, are there any questions? Let me check. Okay, so no questions till this. Okay, So if you have any questions, do post them. I'll check back in a few minutes. So this is the work that was done with my student, Shweta Agarwal. She is currently a graduate student at Maryland College Park. Work was presented in ECR 2018. Okay, so this is the work that was done a couple years ago, and then we are following up on that. Okay. So first, the quick summary and findings of our research. So there are 5 main takeaways from this paper. Okay. Uh, First of all, deep learning based techniques therefore perform far better than traditional machine learning techniques for cyberbullying detection. Second is that most of us have certain intuition about what would qualify as cyberbullying. So people think that use of swear words or having anonymity that would result in cyberbullying, and we have shown that it is neither necessary nor sufficient to have swear words or anonymity for cyberbullying. So even in the absence of swear words, and even with or without anonymity, cyberbullying can still happen. Okay. Third thing, we show that if you go across various social media platforms, say Twitter, Facebook, Instagram, Formspring, uh, Wikipedia talk pages. So these are various types of social media platforms. And if you go across these various platforms, the nature of cyberbullying is different. It's not that anywhere you go and it's the same type of cyberbullying that you'll face. So we experimentally show that these are different types of cyberbullying. And then whenever you look at the data sets for cyberbullying or hate speech, you observe a very clear class imbalance, which means that if I look at the training data sets for almost any hate speech data or harmful speech data, only a small subset of posts were classified as hate speech, harmful speech, or cyberbullying, and a significant part of the data set is actually neutral posts. So whenever you try to build a classifier to identify harmful speech, you have to deal with the, the class imbalance problem. And in this particular work, we show that the oversampling of the rare class actually solve this problem to a large extent. And the fifth takeaway from the paper is that if you build deep learning based model to detect cyberbullying in a particular social media platform, you can actually transfer that knowledge to detect cyberbullying in some other platform. And we have tried various transfer learning methods, and out of that we have found out that the feature level transfer learning is the most effective way to transfer the knowledge. Okay, fine. So let's move further. Okay. So first, let's try to define cyberbullying and why it is important. Okay. So cyberbullying is the use of internet, cell phone, or any other device to send or post text is intended to hurt or embarrass another person. So as compared to general hate speech, cyberbullying is person specific. Here the target is not a large group. So you're not talking about all the people with certain religion, certain race, certain color, certain body features, but the generally target is a particular person. Okay. So that's how cyberbullying is bit different than other types of harmful speech. Uh, and then the various studies which have shown that the effects of cyberbullying can range from temporary anxiety and to something really serious like suicide. So outside computer science, in humanities and other domains, people have studied the effects of cyberbullying in quite depth, even at the school level and so on. So it's a very important problem to deal with. And here are some very concrete numbers to again tell the importance of that. Okay. So more than 90% of the teens go online every day in US. I don't have the exact numbers for India, but I'm sure it would be a significant number. Okay. And then it was found that more than half of the participants, they have witnessed cyberbullying at least once in last year. Okay. And if you look at the left hand side, it shows that the percentage of users that have experienced cyberbullying across various platforms. So Twitter, Facebook, Instagram, YouTube. Uh, and as you can see, Twitter has the highest percentage, followed by Facebook, then Instagram, and then So yes, cyberbullying is present across various social media platforms, and significant majority of the users face it. Detecting the textual cyberbullying, so cyberbullying in terms of text, is a challenging problem for three different reasons. Okay? First is what qualifies as cyberbullying is quite subjective. For example, you might think that use of swear words or curse words will qualify as cyberbullying. But then we have looked at one particular teen-oriented social network called Formspring, and there most of the users are teens in their teen years, and they use these swear words, curse words really casually. So in such context, use of curse words, swear words does not really qualify as cyberbullying. And then we show that in social media, Twitter, people almost never use curse words. They almost never use swear words. But then there is the highest prevalence of cyberbullying on such platforms. So context is very subjective. The definition of cyberbullying is very subjective. Second is the topics that are addressed in various social media platforms for cyberbullying, they are different. So in some places you might be targeted based on your gender, some places you might be targeted based on your religion, some places you might be targeted based on your financial level, and so on. So the kind of topics that are addressed, style of communication across social media platforms is different. So you cannot pick up a particular style and say that, oh, this is what cyberbullying looks like. And third is the vocabulary in social media is very fast evolving. The new hashtags, they come and go, the new trends, they come and go. So something that was not cyberbullying, say 2 weeks ago, might be a bullying thing now. And something that is bullying now might not be bullying after 2 weeks. So things are quite dynamic in social media. So these three factors put together make it really challenging to detect textual cyberbullying in social media. Uh, just we'll have a quick look at the existing work on cyberbullying detection. So various social media platforms, they sort of started within a very short time span of 5 to 6 years. So if you look at the first 5 years of the 21st century, from 2001, Wikipedia, MySpace, Orkut, Facebook, Twitter, all of them were formed in within these 5 years. So those of you who are old enough, they would remember their Orkut profiles, or even MySpace profile. And even before that, there were social media platforms like 6 Degrees, but they were way too ahead of their time. So 15 to 20 years ago, various social media platforms came in picture. And over the next few years, they quickly garnered popularity. And actually, people in other domain, so people in humanities and education domain, they quickly realized that these social media platforms are fertile ground for cyberbullying. So in case of traditional schools or colleges, you would face a bully if you actually physically go to school. Once you are out of the school physically, you are back at home, you don't have to worry about bullying in the school or college. But with social media platform, the kids were not safe even if they are at home, because if they open their computer, they open their mobile, they still have to face the bullies. So it was a serious problem, and it was addressed in humanities and education domain far early. But if you follow the computer science literature, it was around 2009 when the first work started appearing, where people talked about hate speech, cyberbullying in social media platforms. So there was a gap of about 4 to 5 years since the formation of Facebook, Twitter, to the time that people started addressing it as a computer science problem. And if you look at the initial years, people were dealing with data sets using feature extraction methods. So they would have something like TF-IDF and other unigrams, bigrams, trigrams, or character level n-grams. These kinds of features defined for their text. And then they would use various classifiers like SVM, naive Bayes, decision trees, and so on to classify these posts as cyberbullying or not. And then around 2012-13, people realized that Well, we can use something called word embeddings. So you must have heard about embedding methods like word2vec, glove, fast text, and now the language models like BERT and GPT-3. Uh, so it was around 2014 that people started using, started shifting towards word embedding and other methods to represent their text. And then people started addressing the cyberbullying across various types of platforms. And then it was around 2017-18 that people started looking at deep learning based methods. Okay, so that's the very quick summary of the existing work. If you are interested in knowing the details of the existing work, you can go to our paper and then get the details of the work that has been done. But just to give you idea about the work, I will quickly glance you through various platforms that people have addressed. So if you can see the screen, if you look at the third column, you can see which platforms people have addressed. So YouTube, FormSpring, Yahoo, Ask.fm, Twitter, Wikipedia. And then what are the features that are used? So if you look at the features, they are TF-IDF, list of swear words, unigrams, bigrams, n-grams, and so on. Okay. And if you look at the next column, it tells you which models that have been used. So people have used naive Bayes, SVM, decision trees, regression, and then the deep learning based models. And next column, if you look at, it's the list of topics that have been addressed. So it tells us based on what topics somebody is being cyberbullied. So it can be based on sexuality, race, culture, and so on. Okay, and then we'll come back. So if you look at the work that was done on cyberbullying detection, there were three bottlenecks that we observed. Okay, first bottleneck is that well, people address social only one particular social media platform. So you would find a paper that would say that, oh, how to find hateful tweets, or you would find a paper that would tell you how to find offensive posts in Facebook. Okay, so somebody just asked me a question, what is TF-IDF? So TF-IDF stands for term frequency inverse document frequency. So it's a way to represent your text. So what you would do is, if I give you a document, you would just go and count the frequency of various terms in your document. So say word India is there 20 times, word cricket is there 50 times, word tree is there 5 times, and so on. So you would go through your document and create this frequency list. So this is TF part of the TF-IDF, so term frequency. But then you would also go across your whole data set and find out that which terms are frequent and their importance should be reduced. And that's where the inverse document frequency comes in picture. So what you want to do is you want to give more importance to the terms that occur frequently, but at the same time you want to reduce the importance of the terms that occur frequently across all documents. So that's the idea of TF-IDF representation of a document. Okay. Okay, so I'll try to give the details of the abbreviations used as far as possible. Okay. So we observed that people would address only one social media platform. Second problem that we observed was that people were addressing only one type of cyberbullying. So you would find works that would say that, oh, how to find, say, race-based cyberbullying across social media platform, or how to find, say, sexual orientation-based cyberbullying across social media platforms. Okay? And the third problem that we observed was that people were relying mostly on the handcrafted features. So they would say that, oh, we will go and count the frequency of curse words, or we'll go and find out if there are grammatical errors. We'll find out if there are smileys used, and so on. If you look at any work that before, they would have at least one of the three bottlenecks. So again, if you look at the summary given in our paper, in the column for bottlenecks, we tell that each of these works had which of the three bottlenecks. So some of them had all three bottlenecks, some of them had only one of the bottlenecks. But find a work that had cleared all three bottlenecks. And our goal was to do something that would clear all these three bottlenecks. So here is the details about the datasets that we have used. So we use 3 data sets. These are the publicly available data sets for research. So if you just search for the data sets on web, you should be able to get them and download them. Otherwise, you can just contact us and we can point you to the data sets. So first is from a social media platform called FormSpring. Now, this particular social media platform is no more functional. But when it was functional, it was intended for teenagers to use, and it was mainly in terms of questions and answers. And out of 12,000 posts that we got, only 7% of the posts were cyberbullying posts, and 93% of the posts were neutral posts. Second data set that we got was the Twitter, and it had 3 types of posts. So sex-based cyberbullying, race-based cyberbullying, and the neutral posts. And out of the 16 posts that were there, only 31% of the posts were either sexism or racism posts, and rest 69% was neutral posts. And the third data set was the Wikipedia data set. It was the largest one. It had about 100,000 posts, and only 12% of the posts were the personal attack kind of posts. So only 12% of the posts are the cyberbullying posts. So if you look across these 3 data sets, there are 3 different types of social media platforms. One is a question answering forum, one is microblogging platform, and one is a discussion forum. And they address 3 different topics of cyberbullying, and they have different vocabulary. Okay? So these are 3 quite different data sets that we had. First intuition we had was that so the first intuition that, well, use of swear words and anonymity might be able to just tell us which is cyberbullying or not. So if you look at the table, it gives the probabilities of various things. Okay, so first column is probability that given post is a cyberbullying post. Okay, so out of all the posts, how many posts are cyberbullying posts? So FormSpring, 6% of the posts are cyberbullying, Twitter 31%, and Wikipedia 12%. And second column tells us that what fraction of the posts use swear words. So about 16%, 13%, 17% posts, they were using some sort of swear words. Okay, and then what fraction of the posts were anonymous, where we don't know who posted it. So Twitter doesn't allow anonymity, so there is no anonymity for Twitter. But in Forms, about 50%, about half posts are anonymous, and in Wikipedia, 27% posts are anonymous. And then we looked at the various conditional probabilities. So what is the probability of having a post as cyberbullying post, given that it uses the swearing? So probability of B given S. And you can see that this probability for all 3 data is nowhere close to 1. So what will happen is that if we say that, oh, well, if somebody swear words, then it's cyberbullying. In that case, our precision is going to be far, far less than 1, less than 100%. So because the value of B given S is far less than 1, any method that does cyberbullying detection based on swear words will have low precision. And then if you look at the probability of swearing, given that the post is cyberbully post, again, these probabilities are far less than 1. So if you say that, well, in my case, I will consider only those posts that are swearing posts for cyberbullying, then you are going to have very low recall. So any method that does anything based on swear words or anonymity is the same problem. Okay, they would not have high precision, they would not have high recall. Okay, but one thing you have to agree that the use of swear words and the option of anonymity, it definitely increases the probability of cyberbullying, but alone they are not good enough. So they are just indicators, but they are not good enough for the complete detection task. Okay, so we are left with just 15 minutes, so we have to hurry up a bit. Okay, so first thing that we did was that we said that, okay, let's not worry about anything new. Let's look at the various works that exist, and let's pick up the various features that they have chosen, and just apply various traditional machine learning methods. Okay, so LR is logistic regression, SVM, Ways, and so on. Okay, but you can see that their accuracy is quite low. Okay, so we said that let's switch to a different model where we'll use neural network architecture. So first of all, you have to understand that our contribution is not in the model part. So we have just taken the existing models. So we don't claim any contribution in terms of the models, deep learning models. Okay, so we use CNN, LSTM, BLSTM with attention, which are the standard models for cyberbullying detection. Then we experimented with various ways of creating the representation of the text, the word embeddings. So we have used various word embedding methods like random, glove, and sentiment specific word embeddings. And then we had a dropout layer to avoid overfitting of the model. And we used Adam optimizer and a particular loss function. So we had that setup for our deep learning models. And then we did the performance comparison across various models. Okay. So if you look at across 4 types of cyberbullying that we looked at, so there are 3 data sets, but 4 types of uh, cyberbullying that we are talking about. Okay, so bullying, racism, sexism, and attack. And you can see that the performance of deep learning based models is far better as compared to the traditional models. Okay, so if you go traditional models, their accuracy was always below 80%. It was in 70s, and with deep learning based models, uh, accuracy which is going in 90s. So it's a significant jump as compared to the traditional models that were hand extracted features. Okay. Uh, Second thing was the issue of class imbalance. We have seen that only a small fraction of the data was qualifying as cyberbully posts. So what we did was we oversampled the minority class, and we tried settings for oversampling. So 2 times, 3 times, 4 times, 5 times, up to 7 times we did the oversampling of the rare class, and we found out that about twice or thrice the oversampling is enough. So if there are 20 posts which are cyberbully posts out of 100, we'll just replicate those posts twice or thrice. Okay, and then train the model. So with oversampling, there is significant jump in the performance of the model. Okay, so for example, for racism, it was somewhere close to 77-78% accuracy, and it went to 95% or so accuracy. Okay, observe was that it doesn't matter what is the initial word embeddings are used. So when you give the text as input to your deep learning model, you have to represent it as a vector, and that vector representation is your initial word embedding method. Okay, but we observe that if you use a very sophisticated uh, uh, word embedding method, which is SSWE, which is the green bar, versus you use completely random word embedding. So you don't make any efforts in creating these embeddings. You just assign random vectors to the words. Even then, there is no significant difference in the performance of the deep learning model. So which means that the model learns the embeddings for this particular task very well. So you don't have to worry about the initial embeddings. Next, here is the example about what are the clusters that we observe about the frequent words that are used for various types of bullying. Okay, and this tells you that the bullying that happens for various topics addresses various vocabularies, a form of bullying. Okay, so some of these words are really aggressive, but we are discussing cyberbullying, so I had to put those aggressive, offensive words on the screen. But all of us are alert, so we can read these words with context. Okay, so if you see the words used in the sexism kind of bullying, well, you can see that typically women are targeted with words related to women. Okay, again, if you look at the cyberbullying in the context of racism, uh, then again and certain things are the focus. And if you look at just the personal attack, when one person is attacking other person over edit of a Wikipedia page, it's a quite different vocabulary that is used. Okay? We saw that these embeddings that we learn for various social media platforms, they give us quite different word embeddings after learning the model. So meaning of a word in one social media platform is quite different from the meaning or context of the word in other. For example, if I look at the embeddings that were obtained after training the model, and for a particular word, I find out the nearest word or the most similar word. In the slave was the most similar to feminist, religion, Jew, Islam. Whereas in case of Wiki, it had a complete set of words which were most similar. So this tells us that the meaning of the word or the context in which the word is used across social media platforms is different. For example, in Twitter, the word fat is used uh, to describe women or to talk about women. But in Wikipedia dataset, there is no such bias against women. Okay, so Twitter has certain bias, Wikipedia doesn't have. Okay, that's what we are telling. And the last thing is we looked at various transfer learning models. Okay, so what we did was that one particular data set. So we have 3 data sets. Take one data set, train a model on that data set, and now ask the question: how can I use this model to train for us? Okay, so we tried 3 types of transfer learning. Okay, first is the complete transfer learning, and it's the simplest form of transfer learning. So we would train a model on dataset 1 and just directly test it on dataset 2 or dataset 3. So that's the most lazy type of transfer learning. Okay. The second type of transfer learning that we observed was you train the model on first dataset, but only the word embeddings that are learned, and use these word embeddings as input while training the model on the second or third data. And the third was the complete model level transfer learning, where we take the model weights as well as the word embeddings for transfer learning. Okay, so going from left to right, we give more and more information while doing the transfer learning. So if you go to the next slide, you can see that there are 3 metrics that we are talking about, which are precision, recall, and F1 score. And then in columns, there are 3 training data sets, T plus and W plus. So F plus indicates the form with oversampling. So this is a training data set. T plus indicates the Twitter data set with oversampling, and W indicates the Wikipedia data set with oversampling. So we have 3 different training data sets available. And if you look inside each data set, we have columns. We have columns which are titled as TL1, TL2, and TL3. So transfer learning method 1, 2, and 3. So methods which are described in this particular slide. TL1 is the lazy transfer learning. You train a model and you just test it. TL2 is the transfer of word embeddings, and TL3 is transfer of weights and word embeddings. So you can observe that when you use one, it has low recall but very high precision. Okay, and it also gives us information about the similarity the social media platform. Okay, so for example, if I look at the TL1 column for F plus, you can see that the precision is very high when I use the Twitter or Wikipedia data set, which is 83%, 82%. But if I look at the recall, it's 1%, 21%, which means that the nature of cyberbullying across these platforms, so as compared to Wikipedia and Twitter, are quite different. But the precision is very high. Our model is very defensive in labeling the posts as cyberbullying posts. Okay, and then if you are able to lazily transfer from one data set to another, then it tells you that certain platforms are quite similar. Okay, so when you use the Twitter data set and you use to put it to Wikipedia, well, they do far better. And then second thing to observe is that when you use the feature level transfer learning TL2, you see a significant jump in both precision as well as recall. Okay, For example, when we are using form spring dataset, F plus dataset as the training, and you were using T or Twitter dataset as the test dataset, with TL1, our recall was 1%, but with TL2, it jumped to 99%. So it's a significant jump in recall. Similarly, when we're using the F plus dataset as the training and W or Wikipedia dataset as the test dataset, TL recall was 21%, but it jumped to 96%, okay, which is again a significant jump. And third thing to observe, instead of TL2, when you go to TL3, which is model level transfer learning, so along with the embeddings, you also give out the network weights. Well, there is no significant jump in precision or recall. Okay. So takeaway point is that the main knowledge learned by the model while training on a particular data set is the word embeddings. Okay. That's the key knowledge that is learned by the model. Okay. So that's the summary of the paper. Okay. Let me come back to our previous slide. So we we have only 5 to 10 minutes remaining. Okay, so I'll try to wrap up the things. So this is what we did in one work in one particular paper. But for the general audience, what I want to emphasize is that this is a topic that that people should take up for research, and there are many exciting opportunities there, especially if you want to do research. First of all, and that from the computer science perspective, it is a classification problem. Okay, so given a post, you want to tell that whether the post is harmful speech or not. Okay, so any development that happens in supervised learning domain, it can be applied to harmful speech detection. So just look at what are the things that are happening in supervised learning domain, then putting them, applying them to harmful speech detection is careful. It's not that straightforward. It's not as simple as, oh, download any particular classifier and run the code. So some, can you please share the paper link? For sure. Okay. So I will talk with Ranbir and see how I can share the paper or the link with you.
Yeah,
so, first thing is that
we are collecting all the resources from all the speakers and sharing to the participant. So we are trying to do this tomorrow. So this is for the participants. Thank you, Amit.
Sure, that's good. Yeah. So please understand that applying machine learning methods to certain problems is not that straightforward. It's not trivial. So somebody asked where you can get the social media data sets. So in one of the slides next, I will share you one resource. And if you go to our paper, we have also provided links to the data set. But in general, getting data sets for harmful speech detection is not an issue. Now there are large variety of data sets which are available publicly. So now data set is not really an issue. So coming back to what I was emphasizing, many people think that research in machine learning is only about discovering new methods, which is not true. I mean, discovering new methods is a valid research problem, but that is not all. If everybody just invents new methods, use them. So somebody has to apply them. Somebody has to apply them to various problems. Okay. And second thing is that it's a very popular topic. So if you are picking that up as a research topic, it has its advantages. You can publish in many places. You would have easy availability of data sets and various tools. And if you go to various funding agencies, MeitY or SERB or any other funding agency, well, they would be willing to fund your research because it has direct applicability. But it has its own disadvantages. There is a cutthroat competition in this area. So if you look at the state of the art on any standard data set, it gets broken after every few months. So you cannot relax. For example, the work that we have done in 2018, people have surpassed that work in last year with updates, and that's what is supposed to happen. And second thing is that we have to be really cautious about real purpose. Is our purpose just to beat state of the art? Is our purpose just to get 1 or 2% improvement over the existing method? I mean, that can be somebody's motivation, but I don't find that as exciting thing. So when the topic is very popular, you should be really clear about the purpose why we are doing. So in our case, we had a clear purpose. We saw those 3 bottlenecks and we wanted to improve the 3 bottlenecks. And we did not really care about the beating state of the art. Okay. And third thing is that when talking about social media platforms, you don't really have access to the real world system and you are an outsider. So Twitter won't allow you to run your algorithm inside Twitter or Facebook. If you happen to have collaboration with them, only then that is something possible. But without that, you have to work outside the live system. Okay? So now I will try to talk about various research directions that people are pursuing in harmful speech detection. So I'll be quick in just mentioning the various research challenges. So first research challenge is how to exploit the multimodality of social media. So the work that we have done, or the most of the work that we have uh, works that we have reviewed, they are text only work. So they only look at the text of the post and then classify the post as cyberbullying or not. But the social media has many other factors. Okay, so there are images, there are videos, we have user profile, there is also timeline information available. So you can also look at all these things together and then decide if a particular post is cyberbullying or not. Okay, so you can see an image given on this slide. This image is from the paper toward multimodal cyberbullying detection from the Kai conference 2017. Okay, so this is not our work, this is the image from that particular paper. And they have given the example of an image which is posted on Instagram. The image and the post was about somebody who says that, okay, pool day anyone, you will see more of us swimming with rescued dolphins. So it's a very harmless post about swimming with rescued dolphins. Okay, but if you look at the comments which are made on the post, the comments are extremely offensive. Okay, so comments are talking about a particular person in the image and making inappropriate comments about the person. So what this paper has done is that they have actually analyzed the attributes of these images, and they can say that if a certain type of image is posted to social media, it can attract cyberbullying. So even without looking at the post, even without looking at the comments, they can tell that will certain post invite cyberbullying or not. Okay, so they have talked about various types of attributes of images and videos invite cyberbullying. And then there is follow-up work in 2019 in Wisdom Conference titled X Bully, where they do even wider work and look at even wider set of attributes across social media. And they do the cyberbullying detection using extra attributes, not just the text. And again, this is just the beginning. I could find out just 2-3 works that use the multimodality of social media for cyberbullying detection. So it's a topic which is open for research. Second thing is that social media content is multilingual. So again, most of the work that is around, it assumes that the content is in English, and they just go on doing the classification. But now in the real world, the dominance of English in online communication is reducing. So people with their own regional languages, they are participating more in social media and they are generating more content in their regional languages. So the methods that we develop, they should be tailored to the language that is being used. Okay? And then there is very interesting paper I have mentioned here, deep learning models for multilingual hate speech detection. It's a paper from IIT Kharagpur. So they have shown that the strategies that we have for cyberbullying detection for low resource languages versus high resource languages such as English or German, there should be difference in the kind of models that we build. Okay, so it's not like you take a data set of any language and then you go and build the deep learning model. That is straightforward. You have to look at uh, the range of resources available, and then you might have to adopt different machine learning methods. And next challenge is addressing the code mixing. So most of us don't use a pure language. So if you have your kids going to the school, you would understand that they would easily mix the language. Okay, so I'm someone who is from Maharashtra, staying in Assam, and my kids go to English medium school. Uh, so my kids easily mix Hindi, English, Marathi, Bengali, Assamese together. So for them, there is nothing called 5 different languages. For them, it's a soup of 5 languages together, and that's the way young generation now speaks. And when they write on social media, they do it frequently. So they would easily mix Hindi, English, Bengali, Kannada together in a single post, in a single sentence. So how to analyze code mix content is again a very challenging task. Okay. So this ACL 2014 paper is from Microsoft Research. So if you follow that group, you would get a lot of interesting pointers about dealing with code mix text. Okay. And in 2019 in course format, there was a specific paper about hate speech detection in Hindi English code mixed social media. And so again, there is only a handful of papers and very, very few data sets in this area. So again, this is a wide open field if you want to work. And next thing is harmful speech has multiple aspects. So just labeling a post as hate speech or not, cyberbullying is or not, is not enough. So almost all the work that exists does this binary classification. Okay, is it harmful or not? Is it hate speech or not? But then there is a level of severity. Somebody saying that I don't like you versus somebody saying that you are the worst person in the world. Okay, so both of them are hate speech, both of them are cyberbullying, but there is difference in the level of severity. So I haven't seen any work that sort of deals with the severity of the harmful speech. Okay, then we should also understand who is the target. Is the post targeting a particular person versus whether it is targeting a whole community? And especially the social media or the law enforcement agency, they should be more aware about the posts that target a group. And sometimes the hate speech is direct or indirect. Okay, so we should actually build computational methods that can go and analyze all these aspects of harmful speech. Okay, and again, there is only a small number of papers that go and do this part. Okay, so in EML there was a specific paper about multilingual and multi-aspect hate speech analysis. Okay, but again, it's a quite open field. Okay, and then there is also the issue of the bias in your training data set. If your training data is biased towards a particular community or particular style of communication, then your model is going to have that bias. Okay, so in ISEA 2019, again, there is a very nice analysis paper about hate speech detection is not as easy as you might think. Okay, so it tells us about various biases that we have in our data in our model. Okay, and again, it's just one of the first work that has happened in this area. And again, it's a wide open topic if you want to do work. And then we need a niche research that focuses a particular specific problem. So you need to have method, data sets, and end-to-end application, which will deal with a specific problem. So for example, during the COVID pandemic, there is a lot of misinformation going about what is the right medical treatment for COVID-19. So have a system which can pinpoint this particular kind of harmful speech on social media. Okay? And then here are quick resources. So there is a forum called Hate Speech and Offensive Content Identification in Indo-European Languages. So this forum is running for last 2 years and they have annual event. So they give out data sets and arrange sort of competition to build your system. Then second is a link to a website that has a list of various hate speech data sets available. And third is a special initiative by the Ministry of Home Affairs of Government of India, which is about prevention of cyber crimes against women and children. And they have many initiatives going on. They even fund some of the Center of Excellence. So you can go and just check that out. Okay? So these are the few quick resources that you can use if you want to work in the harmful speech research domain. Okay. So that's all from me. I'll be happy to answer questions or the follow-up. Okay. So Ranveer, over to you.
Yeah, thank you very much, Amit, for very insightful and kind of very resourceful talk. So since participant cannot speak, so on behalf of them, let me thank the speaker for a nice presentation. So Amit, there are a couple of questions. So
Okay.
before that, so I just wanted to request you for the benefit of the participants to briefly define the idea of transfer learning, because
Okay.
major component of the presentation was on transfer learning. Maybe in a very short, can you give the brief idea, high level idea of transfer learning?
Okay. So idea of transfer learning is something like that. This. Okay. So for example, if I learn my model on one data set, And now if I have to train my model on other data set, can I somehow use the efforts? Can I somehow use the knowledge gained in training my model on first data set? Okay. Otherwise, there is always a naive method of training my model from scratch on second data set. So transfer learning talks about how I can transfer the knowledge learned while training on data set 1 while training on data set 2 my same model. So in this particular paper, we did 3 different ways. One is only the transfer of weights, then the transfer of word embeddings, and the transfer of word embeddings as well as the weights. But there could be many more ways of transferring the knowledge from one data set to other. But essentially, we are trying to save the efforts. Instead of starting from scratch every time, we are starting from a known point before.
Hello, Amit.
Okay. Yeah. So
Yeah, yeah, that
hopefully
is nice.
that answers the question.
Yeah. And just to supplement to Amit's, now I think transfer learning is one of the important domain, especially for low resource languages. So where, like say, if you talk about Indian languages, right, on these various domain, we don't have resource. So transfer learning is one of, say, kind of important area that you can look at. So with this, Amit, there are a couple of questions. I will just first question is like, say, is information about the user's profile, can it be
Yes.
used for further improving it? I think it's related to speech. So can
Yes.
user profile can be used to improve?
Yes, and that's what is the multimodal aspect of hate speech detection. So many social media platforms they allow you to access certain user information, like what is their location, what is their age, what is their profile picture, and so on. So you can actually gather this information and correlate it to do the cyberbullying detection. Uh, but I haven't seen a systematic work that does that yet.
So next question is about data annotations. So how did you classify the word which comes under cyberbullying and which did not?
So first of all, this this list-based methods they don't really work well. That's our observation. So when we did the experiments, we got the list of swear words and curse words from various popular resources. So I don't remember the website or the resource offhand. We have mentioned that in paper, but it's a fairly agreed upon list of curse words and swear words. We took that list and we said that, oh, now if I build a classifier based on swear words, we will consider these words as the swear words. But when we built our deep learning based models, we did not explicitly mark any word as swear words or curse word.
Okay. So next question is any insight on how hate detection speech done by Facebook and Twitter? If you have information, maybe you can say, but I think it's a proprietary methods. We may
Yeah.
not have full details, but some brief idea if you have, can share.
So I don't really know what Facebook or Twitter use now. I worked in a company 10 years ago, uh, and I would comment. I would guess what they might be using now. Uh, uh, Again, it's a ensemble of standard machine learning models that most of the companies use. But the difference is that, see, when we write academic papers, we try to say that model 1 is better than model 2. Like we try to choose the best model and say that this gives the highest accuracy. Versus what most of the companies would do is they would just use any available model. They might have 10, 15 different models running for hate speech detection. And they would sort of use the ensemble as those models. So most of the academic papers have the focus of building the best model, whereas most of the companies have the approach of building as many models as possible and putting them together to get the best possible results. And there is a lot of work involved in getting the labels for the data. So most of the companies, they would have employees whose only job is to do this sort of labeling, or they would outsource this to some other company, but they invest a lot of efforts in preparing the data and data cleaning. So again, when I talk with some of my friends who work on these topics in various companies, what I hear is that actual model building part actual machine learning part is very small part of the whole effort or the whole process. The significant amount of effort is the data preparation and data cleaning, and then the tuning it based on the user feedback. So in between this machine learning part, we think that it is the only important thing as academics, but it's a very small part of the whole real world process.
One last question from Sarma. So the question is, what will be approximate percentage of learning in transfer learning models and a few applications of transfer learning in day-to-day life?
I won't be able to comment in terms of percentages. I mean, again, we have certain specific experiments and they show how much precision or recall improves. But in general, I won't be able to throw a number. But generally what we observe is that if the two data sets that you're talking about, they are similar, then it results in more effective transfer learning. But I cannot give a specific number as such.
Okay, yeah, I think that is reasonable.
I mean, if you want a real world examples of transfer learning, see, if you know how to navigate in your own city, if you go to a new city, you still use that knowledge, right? The city will have a bus stop, the city would have a railway station, and there are auto. So knowledge that you develop while like navigating your own city, any other city you go to, you sort of use that knowledge. That's a real world example of transfer learning.
Yeah, very nice example, Amit. So yeah, I think since there's no more questions, so Amit, thank you very much. And the participants, dear participants, if you have further questions, you can still post, and I will try to communicate with Amit and get on the answer. Okay. So thank you very much, Amit, for this for a very nice and insightful presentation. It was really a wonderful talk.
Thanks for the invitation. I was happy to deliver the talk. And thanks to all participants for giving the attention. So I'll stop the screen sharing now.
Yeah, that is fine. So dear participant, in couple of minutes, we'll try to start our next sessions. So next session is more of a kind of demo of a currently existing launch system. So this is a tool developed in OSINT lab in the Department of Computer Science and in IIT Guwahati. So since this module has various components, so four different speakers will be speaking about the models and in their expertise area. So before we start, we'll take about 5 minutes just to check whether all the speakers can share the screen and speak out. So please bear with us for 5 minutes.
Ranbir,
Sir.
Amitabh is in attendees area. So Amitabh has to be brought.
Yeah, we have checked and he can speak. So I'll check one by one.
Okay.
So I think I need the cooperation from Naresh. Naresh, can you please unmute Amitav?
Yeah, yes, sir. Yes, sir.
He is in invite.
Because
attendee.
There are some issue in joining.
Okay.
So.
Okay, fine, no problem.
Amitav, can you speak?
Yeah. Hello.
Yeah.
Am I on?
Yes.
Yes, sir.
Oh, okay.
Next, Mala, can you speak?
Hello, Mala madam. I unmuted you. Can you please speak?
Mala is also attendee.
Yeah, because she is having this Linux Ubuntu based laptop, so not able to join.
Where is Mala?
Mala, can you speak? Okay, Rahul, can you speak?
Yes, sir. Sir, can you hear me?
Roshan?
Hello, sir.
Roshan, can you speak?
Hello, sir.
Yeah, so I think we have a problem. Anurag, can you speak? So I think there is some problem with Mala. Let me just check.
Naresh,
Yes, sir.
there are some chat, someone writing that their question is not visible or not received. Something is there. One
Okay,
of
I'll check,
the
sir.
Onamika Moria.
Hello, sir.
Malak,
Can you hear me? Hello.
Malak, Malak, can you speak? It seems Mala session is not unmuted. Can you please check this?
Can you hear me, sir?
Yeah, I
Malak?
can. Mala.
I unmuted, sir.
Okay. So Mala is speaking, but somehow I'm not audible. That is, sir is unmuted.
I
Yes.
cannot hear. I cannot hear Malak speak. That is showing, but I cannot
Yeah, yeah.
hear her voice.
Yeah, I am not audible. That is what she's telling.
Technical issue with, I think. Hello?
Hey, Malak, can you rejoin again? And Naresh, you try it out.
Yes, sir. Yes, sir. I'm trying, sir.
And
Malak,
Naresh, can you unmute Anurag?
Anurag also I unmuted, sir.
Yes, sir.
Oh,
Yes, sir. Yes, sir. Yes, sir. I can speak, sir.
Hmm.
you know? Hey, Anurag, you are not mute.
Yes, sir. Yes, sir. Yes, sir. I can speak.
Okay, fine. Mala is remaining. Then.
Yeah, I think Mala is having problem. Uh, so Anurag, can you cover Mala's part
Or someone else?
or someone else?
Yes, sir. We can cover Malak.
Oh, okay, okay. Then I think we can start. So Rahul, you can share the screen. Let us see.
Sir, my screen sharing is not allowed.
Okay, okay. I think this need to be. So Naresh, please make Rahul as the presenter.
Rahul.
Rahul.
I think Rahul is not in this.
Jumle
No,
Bon
no, no.
Rahul.
At the end. It is there.
Yes.
You from Rahul.
Ha, ha, ha.
Done, sir.
Yeah, Rahul, please share the screen. Share as a screen. Okay, if you share as a PPT or something, it doesn't work.
Okay.
I think you can share the tool first, screen system first.
Yeah.
It's fine.
Okay. So again, good morning to all the participants. So we have arranged this special session from various requests from the participants. So the question, various participant has asked questions about what are the tools and the platform that can be used for social media analytics. So Vish-Shaki is a kind of social media analytics tools developed in OSINT lab, IIT Guwahati. So it has used various platform and tools, and just to give information to the participants and have idea what are the available tools and can be that can be used. Okay, we have arranged this. I think this session will answer many of your doubts in the form of regarding your say platforms and the languages and so on, technology and so on. So yeah, please Amitabh, you start. So let me welcome the
Hello.
team, Vish-Shaki team, and request to start.
Good morning, everyone. So, my name is Amitabh. I'm one of the developers and team member of the Vish-Shaki. So, I'll be delivering a brief intro on what the tool is about, and then let you know about the technology stack that we are using for the development and about the features we are providing through this tool to the users. So the tool is developed at OSINT Lab, IIT Guwahati. We are using some open source technologies and publicly available data for analysis. And we are using Twitter as a source, the data provided by its API. So what is this tool about? So people on social media are posting opinions and expresses their sentiments based on a wide range of topics. By processing this data, one can land to some very interesting conclusions. But this social media data are unstructured and are very noisy data. So this is where our tool comes into the picture. So Vish-Shaki is a social media analytics tool in a nutshell. The tool acts as a generalized framework to facilitate a user to visualize and perform in-depth analysis and gain various insights about various different topics being talked about on social media by the people. So access to this to such in-depth analysis is very useful for different law enforcement, homeland securities, and other relevant agencies to monitor different topics and opinions shared by people on social media. So this was a very small introduction on what the tool is about. I would now like to move to the technology stack that we are using to build this tool. So first, we are, as I mentioned, that we are using Twitter as our data source. So we are crawling data and processing this data using a distributed computing engine called Apache Spark. And to store this data, we are using a no relational database called Cassandra, which is a column-based database. And to deliver it to the users, we have deployed this system as a web application by using a PHP framework called Laravel. So these are the technologies that we are using to develop this tool. Now, I would like to move to the features that we are providing to the users one by one. So as you can see on the screen, this is actually the landing page of our application. This is available for all the public users. Anyone can view this view this portal, because after this there is a we have introduced a layer of authentication and access control due to some security reasons. So we have, after this, we have 5 different modules that I'll come to in a moment. So this is the public page of the system. So here, a user can see what is trending globally right now. Like in Twitter, the topic we are considering every hashtag as a topic. So you can see what are currently trending globally right now. And the graph you are seeing at is basically a frequency distribution graph. That is, you can see the hashtag HBD Megastar Chiranjeevi. So this hashtag is currently trending right now. And this graph is plotting real-time frequencies of the incoming frequencies that our crawler is pulling through the API of Twitter, through the Twitter API. We have in the right side, you can see a few boxes that are top trending security hashtags and communal hashtags. We are actually classifying a particular hashtags into these different categories. That is top trending, the security hashtags which are related to some security issues, and communal hashtags are the hashtags which the underlying tweets are being classified as communal. For example, like there are some people like on social media who post a lot of communal tweets. Communal as in communal hatred, like Hindu versus Muslim. There are a lot of tweets going on. People are posting a lot of hate tweets on social media. So these are the communal hashtags we are classifying as. So we are providing the public a few analysis like frequency, and you can see the sentiment. You can see the sentiment distribution of this hashtag. You can see the top mentions that are being that people have use in their tweets. You can see the location if only the user has shared their location. You can see the active users, who the number of users. Like suppose if there is a bot on Twitter, you can see a lot of bots posting about different business profile from different business profiles. Are yeah, like after every 1 minute they are posting a lot of tweets. You can find out fake profiles from there. You can also see the raw tweets that are being used for this particular hashtag. And finally, the network information, which I'll come later on. This is actually for the authenticated users. As I mentioned, that there is a layer of authentication in our system. So this is for the public users. Currently, the interval is 15 minutes. You can shift this interval for this window for 30 minutes, 45 minutes, and so on. So now I would like to move to the after for the authenticated users part. So first we have the location monitor system. Rahul?
Yes, yes. Since
Sorry. So first is the location monitor system. What this module is about, like if I ask you, what are people posting about, what are the people from India are talking about today, right now? So this is a module which actually answers that question. So who is Adi Ganesha? So I think there is some hashtag which recently arrived. The people are talking about this hashtag a lot from India. So likewise, from different location, you can select a particular interval. From like suppose Delhi, you can see what are the people are talking about. So this is what that module does. Uh, the ideology behind this module. So next module that we have is the trend analysis module. So the module. Okay, so this is the module. So in this module, a user can set the from date and to date, and over that range of dates, the user can query like if what were the trending topics that were going on. So suppose like if I query on in the month of January, like citizenship amendment bill was trending. So likewise, a lot of trending event goes on for a range of dates, so we can see that via this module. So this is the main intuition behind this module. That is a trend analysis. So okay, so these are these were the trends that were going on during that range of dates. So example is stop portraying assume negative. Next, I'd like to move to the historical analysis module. So this is one of the most interesting module in our system. What basically it does is like it analyzes historical data based on a hashtag for over a range of dates. So suppose I search for COVID-19, and you can see that the COVID-19 tweets initially started from, Rahul, could you zoom to the graph? Initially started in the month of February. So you can see that in the month of February, February 15, the COVID-19 tweets actually arrived. And you can do a lot of other analysis, like finding the sentiment. You can see the co-mentions that the users has used, the co-hashtags that all the users has used in the tweets, the active users, and the tweets, and a location if if the users has shared. So these are the sentiments that were posted by the users and with their tweets. Next module is the network analysis module. Uh, so, yeah. So next module is the network analysis module. So as we all know that social media data is very highly relational, and if viewed as a network architecture, one can gain a lot of relational information from it. So network analysis allows you to analyze various networks obtained from the system. Like I showed you, there were some co-mentions and co-hashtags generated. These are actually the network for a particular hashtag. So one can obtain a network from our system and could also import from external sources as well. So this module allows you to perform different analysis, like finding out centrality, community detection, link prediction, shortest path, and likewise there are many such analysis. So in a moment, my teammate Roshan will go much deeper on what this feature, what this module provides, more, other than this modules, other than this analysis. So next, I would like to move to the user analysis. So user analysis is basically a module which actually tracks down user activity. So over a range of dates, the module will give insights about what the user has posted, how many tweets he has posted, what are the different hashtags the user had used, the sentiments of the tweets. So, for example, Arvind Kejriwal, you can see on the screen, like for a range of dates, he has posted these tweets. We have the sentiment embedded in on the tweets. You can see there is a yellow dot. Yellow dot actually signifies here that this tweet is basically a neutral tweet. So we have three classification: positive, neutral, and negative. So this tweet is a neutral tweet. So and you can see the co-hashtags, you can see the co-mentions, and the location only if the user has posted, and sentiment and frequency information as well. So this was actually a very brief introduction of what the tool is about and what the modules are actually doing. Now my teammate will explain you how we are importing the data from Twitter and various sources. So I'd like to pass the
Yeah,
pass.
since Mala is able to join, so Naresh, can you unmute her just for one last testing?
Yeah, sure, sir. I'm doing.
Mala, can you speak? Hello, Mala, can you speak? Mala, can you speak?
Madam, you are unmuted now. You can speak.
Mala has two entry. Mala has two entry. One you have unmuted.
Oh, Mala has joined in the panel list now.
Oh, then no problem.
No, but she need to be unmuted. She is in the panel list now.
Sir, panelist can self unmute.
Hello, sir.
Yes, yes.
Now
Am I audible, sir?
Yes. Please start.
Good morning to all. So basically, we are crawling. We can crawl some of the data from our social media platform. So like we have like Twitter, YouTube, and also we have Facebook, and others are Instagram. All those social media platform we have. So they provide some APIs. By using them, we can crawl their data from their side. So like for example, the first API we are using is that Twitter API. So using this Twitter API, so what we can do is that we can retrieve the data from the API, and we can analyze the data. So like from using this Twitter API, what are the things we can get from the Twitter side? We can get all the information about the tweets, like who is tweeted, the original tweet text, and from where the person has tweeted, if the person has shared their location, and the other when the tweet is tweeted. All those information we can get from this by using this Twitter API. And other thing like users, all the users information like user profile image, user screen name, username, and user description. All the user have their description, means who they are. So all the information we can get from by using this Twitter API. And others all the followers list of a user, all the following list, and what are the trends going on in the worldwide. That also yeah, Twitter provided. So that information also we can get from this by using this Twitter API. So these are the things we can get. Next slide. Mhm. Yeah. Twitter have their two version. One is the community version, which is open source, and by using this we can get only the limited data, because this is open source version. And like if Twitter has the 100% data, in the community version we can get only 1% of data. But that will be very huge. Like we are crawling since 3 years, so now we have almost like millions of data. And the second one is the enterprise API version. This is the paid version, and this version have more features, but we are not using this. And the Twitter API have two features, like one is the streaming API, and another is the search API. What is streaming API is that streaming API is like you can want to get the tweet of a person, like suppose our Prime Minister Narendra Modi. You want tweet whatever he tweeted anytime. So whenever you follow Narendra Modi by using whenever you want to crawl the data of Narendra Modi by using this streaming API. So at the time when you started streaming, from that time whatever he tweeted anytime, so that all the tweets you can get by using this streaming API. But the purpose of search API, the disadvantage of streaming API is that you can't get the data. You can get the previous data. Like today you have started the streaming, so from today you can get the data. Go on, but the previous data, like yesterday or the previous month data, you can't get by using this streaming API. So for that they have provided they are providing search API. But in search API, the community version provided only 1 week previous data, but the enterprise version have more flexibility to search the data from even from previous months or previous years also. Yeah. Next slide, please. Rahul.
Meda, can you please speak bit louder?
Yeah. Okay. Hello. So
Yeah, please,
now,
please, please.
am I audible? Hello.
Yes, yes. Now it is perfect.
Okay. So how you can use this Twitter API is that if you search on Google like Twitter API, then it will provide one portal, is that developer.twitter.com. So there you can get all the information about how to use their Twitter API and what are the things they have provided. All the detailed information you can get from that website, that portal. So I will describe that step by step, describe that how you can use the Twitter API. So first of all, you go to that link and first of all you need to have one Twitter account. So by using account, first you go to that link developer.twitter.com. There you have to first create one project. If you have your developer account, then you need to create project. After that, yeah, in that project you need to give some details that what is that project, and what are you doing, what are you going to do with that project. And they will ask you that why are you crawling data, so you must provide on what purpose you are crawling their data. So those are the information you have to provide while creating this project. So after they approve this creation of project, then you will get some credentials like consumer key and access tokens. So by using these two features like consumer key and access tokens, you can use these two keys. You have to use these two keys, credentials, in your while crawling your data from the Twitter side. So yeah, in the next slide, Rahul. Yeah. So this is the portal I'm telling about. That in this portal you can create. I have created three projects. So based on that, they have provided all the keys. So you can create as many as project, and yeah, on that project they will provide the consumer key and access tokens. So you have to save those credentials, and you have to use those credentials while you are crawling the data from Twitter by using this Twitter API. Yeah. So now I'll show the little bit of demo, how you can use that keys, and how you can crawl data using some other languages, some yeah, here we are using TweetPy, which is Python library. You can they have JavaScript library also, and you can Java library, you can use that also. So by using this TweetPy, you can crawl, like you have to give this like consumer key you have to provide here, consumer secret key you have to provide, then access token you have to provide, then access token secret. So these are the credential you will get from there in that portal. So you have to first create that project, and you need to get those keys, and you have to provide those keys here, so that you can crawl. So after that, this the how you can write the how you can call their function, how you can use their function. So all those details you can get on that website, developer.twitter.com. So there, from there you can get all the information that how you can use their functions. Like I'm using Twitter is the wrapper on Twitter API. So you can use this Twitter, or you can use their Twitter API raw. But if you use their Twitter API as a raw, you have to write you have to handle more things. So it is better to use already developed some wrapper which is popular. Like Twitter is very popular. So using Twitter you can get the data. So these are the some snapshot of our how we are crawling. So like Twitter, you have to give this consumer key, then you have to crawl. If when you crawl data, then on this on data function you will get the data, and on that function the function will provide the data. A function will pass the data to some other function, then it will just store the data. So like this way it will store, and it will collect, and it will store the data to our like some storage device or some database. So the purpose of showing this snapshot is just that you have to use that consumer key. So how you can use that consumer key and how you can get the data. So this is the purpose of showing this snapshot only. And here you can see that this is the code of the streaming API. We are using the streaming API, that's why we have the snapshot of the streaming API code, but we are not using the search API. But you can use the search API also to get the data from the previous 1 week, or some if you have the enterprise version, then you can get the data for previous months or previous years also. Okay. Okay, next one. Yeah. So these are the some yeah, these are the some links, some references you can go through this go through this portal. We'll get all the information. So what are the information Twitter provided in as a tweet, as a user information. They have provided all the place information also. They are providing they provide all the, like in Twitter, many of the people uses hashtags. They have mentioned they mention some other users. So all the things you will get by using this Twitter API. So what are the things you will get? You can go through these links and you can get all the information from these portals. Yeah. Okay. Rahul. The next API is the YouTube API. So YouTube also have their own API to collect the data like comment and reply, the video information, and what are all videos in a channel. So all the things you can get from by using this Twitter data API. Please go to the previous slide. uh, Rahul, previous slide, previous. Yeah. So this is the portal of their APIs, YouTube data API. So by using this API, you can crawl comments, replies, video information, all those things. So the procedure of to use this data API is same like Twitter API. So like you have to first create your you need to have this Gmail account. So you first log in through Gmail account, then you have to they have their developer portal also. So here in this page you can get the link of their developer page. You have to go to the developer page and you have to create some project same like Twitter. So they in YouTube also in YouTube API also, they will provide, after creating project, they will approve your project, and they will provide some credential also. So you have to use that credential to crawl the data from the YouTube API. So it is just same as Twitter. So the library we are using for YouTube data API is it is Google, it is Google API Python client. So this is the library of this is the Python library to use the to crawl the data from the YouTube API. You need to just install this Python library, and after that you can use like in Python you can use this library as like Twitter. We have just shown that you can use TPI library to crawl the data from Twitter. The same as like you can use this YouTube Python library, Google API Python client. You can use this library to crawl the data from the YouTube site. So it is same as just like Twitter API. And the next API we have, yeah, Facebook API. So Facebook also have also provides some of their data. So they have also some restriction to provide all the data. So like you can crawl the public data. You can crawl is like public that group the group which is publicly available, and you are the member of that group. You can crawl the data from the group. So that type of restriction they have. So they have more restriction. And I don't know what are the all other restriction the Facebook API have. because we are not using this Facebook API, but our OSINT lab members, some of the lab members, they have used this Facebook API so to crawl the data from the Facebook site. So you can use this Facebook graph API to crawl the data from the Facebook site. The procedure of this to use this API is the same as all other API. We have they have also their developer account. You have to go to their account, developer account. You need to create you need to create one project. They will approve that project. They will give you some credential, and by using that credential, you can crawl the data from the Facebook site. So so at the end we can say that you can use means every social media platform have their own API which you can use to crawl the data from their platform. So but they have some restrictions, so you need to go through their documentation. They have written very gratefully, very cleanly, so you can go through that. And all API have their own library, Python library, Java library, all have their own library. You can use those library. Like Twitter have TweetPy, then YouTube have that Google API client, then Facebook also have that YouTube that Facebook graph API. So these are the library you can use to crawl the data from this social media platform. Yeah, so that's all for to crawl the data, how you can crawl data from different social media platform using APIs. Yeah, so yeah, that's all for me. So now my another mate will give you some analysis on how we are, after crawling the data, how we are processing them, how we are getting all the process data, how we are analyzing them. So that knowledge, that information, the my other mate will give you. Yeah, thank you all.
Hello, good morning, everyone. I'm Yumlem Raul. I work in Ocean Lab as part of the Vish-Shaki team. So today I'm going to briefly talk about Spark. Uh, so Spark is a general purpose cluster computing engine. So like it works with Java, Scala, Python, and R language. So it is a distributed framework. So it also support like a higher level to like Spark SQL. Like it is very similar to SQL, the normal SQL, but it is a little bit different, and it also have other libraries like machine learning lib for machine learning. So in this machine learning lib we have some only basic libraries, and GraphX for graph processing, and we also have this Spark streaming where we can stream data. So the main concept of Spark is RDD. So it is resilient distributed dataset. So what RDD is basically, in a summary, a list that is divided across different machines. So it is a distributed framework. So this RDD will know in which part of the in which machine which data resides. So RDD is a concept where it encapsulates all the distributed nature of the data. So just give me a second. Uh, So the main component of Spark are like Spark Core, Spark storage system, and cluster manager. So in Spark Core, they have different APIs in Spark to perform operation easily. So in Spark Core, they provide APIs for the underlying API for computation with Spark. And in storage system, you can have a distributed file system. So it is very necessary that you have a distributed file system or distributed database like HDFS, Cassandra. And we also have cluster manager where we want to able to like manage the cluster in a way that it is fault tolerant. So we should have a cluster manager. Spark provides its own cluster manager. If you don't want to use the cluster manager that is provided by Spark, we can use like Mesos, then Yarn. So there are different cluster manager that we can use for Spark. So this is the overview of the Spark system. So at the heart of the Spark system, there is Spark Core, which provide the API of Spark computation system. Spark streaming is there, Spark SQL is there, machine learning lib is there, graphics is there for graph storage system and cluster manager. So this is the whole Spark system. So like I want to briefly talk about resilient distributed dataset. So what is resilient distributed dataset? So it is a distributed how to distribute data across cluster, fault tolerant. So how it is fault tolerant, I will talk about that a little later. So it uh, it it knows like the execution plan. So in Spark we always have an execution plan, so it remembers the execution plan, and if anything fails, then it retries that fail part. So it is a fault tolerant system. Then it can efficiently process billions of rows of data. So think about, like, if you work with Excel or Pandas, and if you have billions of rows, and if you want to process with Python, so you have to like you have to know which part have you processed, which part you have not processed, which part you have completed processing. So all those things we can Spark takes those take care of those under the hood. So you don't need to worry about like you don't need to worry about all those things. So how many have I processed up to? So there is no way that in a one machine you can process data. Uh, so this is the main advantage that Spark have. So this is an example. So this is a data frame that is distributed across 3 nodes. So it will distribute across like this. So it is also the main thing about RDD is it is immutable. So, what it means is it cannot be changed. Like suppose in a list you can assign a value. So in RDD you cannot change. You can only convert you can transform one RDD to another RDD. If you want to change, you have to create another RDDs. And it is lazy execution. So execution. So suppose in this formula we have this xi square. So in this BG execution we will square them and we'll add them. But in lazy execution we perform the square for only 2, and so it will go something like this as shown in the slide. And now I want to briefly talk about I want to show a sample code. Like this is a Python code. So suppose it is a very simple Python code where I have a list of strings and I want to convert into uppercase letters. So this is the output that I want. So basically we'll write a Python code like this in Python. So how do we write the same code in Spark? Like this. So suppose we have this I have never seen a purple cow. I never hope to see one, but I can tell you anyhow, I rather see anyone. So suppose this text file. So how do I convert the lines that start with I with capital? So first of all, while writing a Spark, you need to create a Spark context. What is Spark context? So Spark context is nothing but an instance where you specify all the things necessary in your in that program. So suppose if you want to connect to a database system, then you need to specify the IP address, the password, and all those necessary metadata of your program during creating the Spark context. So Spark knows what you have to search for and what you have to deal with. So first you need to create a Spark context. So SC is the Spark context, and this conf is this Spark context. So what I'm setting is I set my master as local. I set my app name as my app, and I have one executor. I have given the executor memory as 1G. So when creating the Spark context, we need to specify all these things. Then using the Spark context, I the content of text file is shown in this left side. Then what I do is I filter lines with I. So since the line that started with I contains only three here, so when I count that, it gives 3. 3. So this is basically how you write a Spark program. And this RDD immutable lazy execution. Then this liners. What is liners is like when doing this in this program, what I did was map lambda line dot upper. So I converted all the line to upper. So while doing this, it will convert all the line in my text into uppercase letter. Then I filter out all the text that start with I. So and I count how many of them are there, all the line that start with I. So it gives 3. So what it does is it have map, filter, and count. So what it does is it will give the first RDD applying map. So it will convert into a second RDD when applying map, third RDD applying filter, then fourth RDD applying count. So it converts from one RDD to another RDD to another RDD. So it is immutable, lazy execution, and it creates a lineage. So suppose if it fails due to some reason, it applying map, it will it will again retry applying map. So it is fault tolerance in that way. So this RDD can hold any type of like some primitive types like integers, character, boolean, and it can hold also strings, this array, tuple, dicts, and like if it is serializable, if your data structure is serializable, it can hold that too. And it also have some mixed types like peer RDDs like this panda one, ping one, pirate one, panda one. So this is some mixed type, and it can also key value pairs. So panda 0. So the examples shown here, we can also have key value pairs. Explain this key value pair. So what it is doing is when it is reduced by key. So suppose panda value is 0, panda value is 1. So panda value is 1. So when it does reduce by key, it will reduce to 1 too. So if you can see the example, so I will talk about reduce by key a little later. So how do you create RDD with PySpark? You have to create a Spark context, as I said previously. So this is the Spark context. Then you read the data, you count file. So RDD, you need to create a Spark context first. Then I will talk about RDD operation. There are two types of operation. One is actions and transformation. Basically return values, and transformation convert a new RDD to another RDD. So this my data.count is an action operation, and action operation. So count returns the value, count take n. So so this is another filter example where we want to filter word that contains Spark. So if I give if I created a Spark context here, then I parallelize them, it basically creates an RDD. So I do words dot filter lambda x Spark. So it will filter words that is with Spark. And another thing is, if you don't do this line word dot collect, it will, even if you execute this, it will not perform any of the operations. Spark doesn't execute unless you specify an output operation, an action operation. So it will basically remember the lineage in which order in which order we are going to execute the program, but it doesn't execute unless you want the output, you do some output operation. So there is one of the features of Spark, and some of the actions that I have listed. And I can functional. If I have this my data in my data, I have an idea this RD, and if I want to convert it to uppercase, then write this is a normal Python function to convert string into upper. Then I can do, and as I said, this take 2 is necessary to execute it, so it will execute. It will yeah. This is an that it prints the output. So this is how we do functional programming in Spark. Necessary Spark data frame. So it in Python, executing in RDD and executing in data frame is a little bit faster, a lot faster in your program RDD, because it is very difficult to know how you optimize your RDD implementation. So Spark framework have provided this data frame API it is basically like Pandas API in Python. And what it does is you specify you write some SQL code, and it will convert that into an RDD operation that they have implemented in an optimized way. So so Spark data frame. So how do you create how do you create a data frame? So if I have this list, then RDD.2df, and if I show the data frame, it will give a data frame, a pandas data frame, like name equal to Osman, s equal to 21, row name equal to Ahmad, s equal to 25. So you can also convert your data frame into RDD. You do df.rdd.collect. So this is Spark data frame, and I will talk about Spark data frame. So this is one use case that we are using. So suppose count, tweet ID list, class created, and so want to aggregate those hashtags, which these are for a day. So if I want to aggregate those hashtags, the count of those hashtags that came in a day, then what Spark data frame provide is like you can just write one line, select token name, some count from token count. This is the data that I have group by token name. So this is a normal SQL code that you can write to just count. And other options like if I have to also aggregate this tweet IDs. So there is you have to write another SQL code, like something in that way, and you have after getting those two data frames, you have to join them. So so this is how easy it is in Spark data frame counting the hashtag. If you write in Python, you have to you have to write a lot of lines, but here it is just one line to count. So this is Spark data frame. So in Spark streaming, as my colleague have told you, like we are streaming the Twitter from Twitter data from Twitter, and like how do you process those Twitter data? So case we chop up. So we thought that we'll process every 10 seconds. So Spark is nothing but like a deterministic based job, and it will chop up the streaming into small data chunks, and it will perform some kind of operation on this, like counting, aggregation, or you can do some form of computation on top of this. You need to chop up that streaming data. So why streaming is necessary is because if we do it in by writing in Python, you have to take care of lots of things, like while streaming the data, one of them. So Spark take cares those things in Spark streaming. So 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 in Twitter streaming, so if I say for 10-second base, I have divided into 10-second base. So 10 base I got hashtag 1, hashtag 2, hashtag 3, hashtag 4, and I got an empty tweet that does not contain any hashtag. Then what I will do is I will flat map it. Flat map it means like we have to convert list of lists into a list. Then I will index them. I will do reduce by key. So suppose hashtag 1, hashtag 2 came twice. So the count of hashtag 2 is increased when I do reduce by key. So hashtag 2 is the key. So here hashtag 2 is the key. So this processing will from in the next 10 bits, another processing will be done, and so on. So very easily you can reduce you can do computation on your data. So this is an example of Spark streaming. And so this is the basic structure. So you have to specify from where you have you are streaming the data. You have to specify the connection host where you have where you are going to stream the data. Then you have to specify the base. These are in seconds. So we what I'm specifying is I want to chop up the streaming into 10-second batches, and this is the port number that I'm going to listen to. And I will be receiving a JSON as a streaming data. So I load the JSON, and it will convert into another stream. And when I will get combine stream.map get hashtag, what it does is it will return all the hashtags. So this trending stream will contain only hashtags. Then what I do is from this trending stream, I do flat map x comma 1. So it will index all the trending stream into like as I have shown in the previous thing, indexing, something like this. All the things will contain something as this. Then after that I will do hashtag. Hashtag is the new stream, and after that I will do hashtag that reduced by key. So after I do hashtag reduced by key, I will get the count. So this is a basic example of Spark streaming, how easily it is done. And deep learning in Spark. So the ML library in Spark does not contain any deep learning framework. You have to, other third library, third party library. So these are some of the deep learning library that is available. LFS, Yahoo, for Yahoo, you have TensorFlow on Spark. You have for Sun, you have distributed Keras, and from Intel, you have Big Deal. So these are all implemented for Spark. So we are currently using Big Deal. So what is Big Deal? So like it basically specify how to run big data deep learning on big data platform and easily integratable with big data ecosystem, and massively distributed, and it also sends compute to data. So instead of sending data to the computation, it sends code to the data and execute locally. So if your data is distributed, it will not retrieve the data to the master, and it will not execute. It will send the code to the data and it will execute those data. And it is fault tolerance, incremental scaling. You can also scale incrementally, dynamic resource sharing. So these are some of the features of Big Deal. So in one of the things that they have improved from in terms of parameter from Spark Live is like in parameter, the weight are all the weights are delivered to the driver first, and it will compute the gradient and all the updation, and it will give to the worker. So the bottleneck here comes is like executing everything on the driver while doing a weight updation. So this is one of the bottleneck that Big Deal have solved. Uh, So in Big Deal, the gradients are computed. The gradients are computed on the local data on each of the local machine, and only the synchronization is done by the parameter server. So this is an overview of how deep learning are implemented in Spark. Since most of the weight updation are sequential, so we need to have this parameter server to to exchange the weights and all. So this is a programming API example of a Big Deal. So if the basic example like y equal to wx plus b, you can do module linear 3 comma 5. So this module dot forward, I generated a 3 comma 1 data, and it will just compute y. This is like it is very similar to Keras. So this is a programming API example of Big Deal. And next, if you already have a Keras model, then you can you can just import, you can convert them into a Big Deal model by importing the JSON part and the HDF5 part, your weights, by doing model load Keras, then you will get a Big Deal model. But some problem here is like if you train your Keras in I think this Big Deal model use Keras 1.2, so you have to train your model in Keras 1.2. So those are the disadvantages that is currently having in Spark in terms of deep learning, because they are not updating the APIs as like as other deep learning model that people use, Keras, TensorFlow are using. So they have not updated that much. So you have to check in which Keras version that your model is trained. So this is basically an overview that our system is using in terms of Spark, and so this is basically my end of presentation. I will next Matt will talk about Roshan will talk about a network. Hello.
No, Rahul, you can stop the screen share that I can share my screen.
Okay, okay.
I will request whether I am provided with the permission to share the screen or not. It's Roshan Singh.
Roshan, your audio is distorted.
Hello. Hello. Am I clearly audible?
Yes, yes, yes. You can start.
Sir, I would like to confirm that I have been given the permission to share the screen or not.
Just yeah, okay. Just check if you're able to share.
I am not able to share, sir.
Naresh, can you please change the permission?
Yeah, to whom should I assign, sir?
Roshan Singh.
Now you can do it, sir.
Roshan, you can share your screen now.
I think my visible. I hope so. So, this network analysis section from this project, my colleagues has discussed about all these various modules that are part of our project. So, network analysis is one of them. The importance of this network analysis, why it is much important in case of social media analysis is that the social media itself is relational in much sense, and that can be much better represented in form of networks, where the networks are connections among the entities that are part in the social media platform. But in the case like we have in case of Twitter, where we are in particular working on, so we have these entities of hashtags, mentions, keywords, and user, and so on. So these are the entities, and among them we have some sort of relation, like the user follows another user, a hashtag co-occurs with another hashtag, and so on. So we have in this particular tool, just to give you a brief sense about what is this problem and what how we are handling this issue. So like we have got something Rajput list. This hashtag something Rajput is a particular hashtag that is being used to represent some Rajput murder or suicide case. So say I want to generate a network of all the hashtags that are being used with hashtag something Rajput. So we have various network twice provided here. So we can get from hashtag or hashtag mention and so on. So the network generation is a time consuming process. So for to consume less time, I have already generated some network. So first one is this hashtag network of something that. So upon view, we can see this network here. So this is the hashtag network. So this is a network of something that all the tokens networks are being a part of something network that are being shown here.
Roshan, can you zoom the network part? It is small to see. Network that visualize that network
Yes.
graph.
So at my end, I am having so probably in time.
Oh, okay. No problem. No problem.
So we can zoom that. Okay, so we have. I think it is. I think it is.
Mala,
Mala,
Mala, can you mute your mic?
So I think the network is visible now. So this is our network where hashtag something. So what we did is that we queried for our hashtag, and we found out all the top 50 hashtags that were associated with that particular queried hashtag. In our case, the queried hashtag is something Rajput. So from 1st of August to 22 of the August, we are going to get a network, and we have got a network for that. And these are the network of top 50 hashtags that have co-occurred with something Rajput. So this is in the network form you can see, and we can also see it so information. Okay, we can see here how many edges they were, how many edges are there among these relationships, among these entities. So in total, we have 50 nodes in our network, and we have got 664 edges in the network. So this is some network information that we can give. Now we have to get some more insights upon this network that we have generated. That is like the central nodes in the network, or the important nodes, that what are the important nodes there in the network. That information we can obtain. So for that, we have this already implemented used this degree centrality mechanism from Network X. This is one of the library for network analysis. So I'll be talking about that also, some demonstration too. So I will be discussing in a few minutes. So here, this we again get the same network, but this time the size of the nodes are much different. Some are larger and some are smaller. So this has to this is intention is representing that more the much larger the size of node is, much important the node is in the network. So we can see this particular information here. Like now again for 664 edges, but now we have got in a serial where some serial of nodes in a sorted order. So this sorted order is based upon the importance of that particular node in the network. So we can see something Rajput, this case, they are some nodes that, for example, consider the top three nodes, the something Rajput, this case, and etc. They are much important in comparison to rest of the other nodes in the network. So these are much later, like all the members in the case. We can see that we can get an intuition about whatever happening in this news and whatever is going on the news channel, and from Twitter information we can and we can some make correlate them. So this is one of the information I would like to I would have thought to shown you and had found. So one more interesting is like seeing that persons think about the particular hashtag. So this is much interesting to see who are the top persons that are talking about hashtag something Rajput or something Rajput guest case. So we can clearly say from news channel especially, like this NDTV we have got here. So because of the debates and all, they are talking about something that case. So this information is NDTV provided here, and so on. So this is a few implement a few functionality of our module, in particular network analysis module from our good business. A lot more are there, but due to time constraint, I cannot show. But going to the implementation part, so how you can use such open source tools and methodologies to calculate and to work upon the network information. So I will be going one by one. So just to give a brief insight, we are using we have used two network analysis components. One is Network X, and second one is the Apache Spark. So I will be touching upon them. First, the Network X, the frameworks and the use. One is, as I have already mentioned, the Network X. It is a Python library for network analysis. Second one is the Apache Spark Graph Frames. So it is a distributed network analysis package for Apache Spark. As my colleague has earlier explained in much details what is Apache Spark. So this graph frame is one of the libraries, one of the packages that you can import in Apache Spark, and you can work upon them. So this is about the analysis and the framework and the tools for analysis. So the next come is the visualization. If time permits, I will also go in much in the visualization part. So I start with the Network X. To generate a network, we need sort of information, in particular the relational information. So this relational information can be given in sort of matrix or in sort of edge list. So in our work, we are dealing with edge list in particular. Now here on my screen, you can see some information. So here are the, so this particular information is a relational information of relationship between two persons, or or you can consider this as an offensive network where Anjali is a friend of Shyam, and it is a bidirectional network. So like Anjali is a friendship of Shyam, so friend of Shyam, so Shyam is also a friend of Anjali. So it is being represented only one. Similarly, Cynthia is a friend of Samir, so this is being represented in form of age list. Now in network X, want to generate the same network from this age list. How we will generate that? So for that we have to import this library. Like we have to import network X as NX as the network X library and the pandas for reading the age list file and creating the data frame and creating the graph. So we have written a function for this that will generate a network from this file where this age list file is passed over here. Now once we have this age list file, uh, we can see this here. So I am basically drawing this network on the screen, and we have got a different layout and different layout for accordingly for a particular specific visualization. Like in this case, I am drawing a string graph, and we can also go for some other graphs, say regular. Like it is there. String and different layouts we can you can get in the documentation in a specific like what are the different layouts in which you can visualize the network in. So this is the of the network. Now coming to this information about the network. So we can get this information like whatever the edges that are present in the network. So that information we can obtain from like this, like the graph presented by G and all the edges present in the network. So G dot edges. Similarly, we can information like nodes. So all these nodes present in the network we can get, like we have 8 nodes in the network. We have in total 8 nodes here. So we can also add some edges, like we can add an edge from by this notation. First one is the first node, second one is the second node. We want to create an edge, so we can create like this 0. Similarly, we can remove remove edge, that will remove a edge. Now coming to the analysis part, like how to calculate the degree centricity. Network X provides one API for finding the degree centricity. When we pass this information, when we call this function, so this will return us some values. So this value corresponds to the importance of node in the network. Like higher the value, more important in the network. So in our case, we can see Rajiv node.
Roshan, yeah, I think you need to speed up because of the time. Huh? Thank you. Thank you.
Yes, sir, I will take it. So it will give us some information. So this numerical values that will tell you about the importance of node in the network. This is one of the case. Next, we can also use network X for finding this for link prediction, for finding links that are not now connected, but in future there is a high probability that they are going to be connected. So I have also done for this, and now you can say some value. The highest value is I think the Syam and Aditi and Rahul and Shyam. So these are not connected. Rahul and Shyam, they are not connected, but it tells that in future they are going to be connected. So that information we can obtain. So a lot of a lot of things are there in network X that you can find from the documentation. It is having a very detailed documentation in such. So just to I am not able to get okay. So coming to this part, I will not take much time, more 5 or 5 minutes. So So I have talked about network X. So another is the Apache Spark framework. This is a distributed framework where we can compute this network information. So this is for basically for big data. Talking about big data, where network X that will not scale. So we have to calculate our network. We have to calculate the information on the network in a distributed manner so that the resources are optimized. Resources can be used in a proper way. So we have got the Apache Spark. In Apache Spark, we have got a package called the dataframes. So that is for distributed computing of network information. So for that, you have to import this dataframes package. By this information import, you can import. Then we have to create the graph. So here I am not importing from the ISEA, but I am creating from the data frame by giving the user input. Like this is like a person. This is the friend. This is the same graph like earlier, but we have some information in the nodes like Razi from Kolkata and Anjali from Guwahati. Like this, we have information. So this is a node, and this is the ISEA information. So now, how a graph is created in Apache Spark by calling the function graph frame where the information of vertices as the information edges are passed. So that will give us a graph. Now we can see all these nodes. So now coming to the degree centrality. So the nodes can be seen like g dot nodes dot show, that will show the all the nodes. But now coming to the degree centrality, here we have got the function of d dot degrees dot show. So earlier in network X it was showing some normalized value, but it is in this case it is going to show the complete value. So Rajiv is having 4 connections, like he is having 4 degree is 4. Similarly, the vertices, as I already told, so the d dot vertices dot give the all the vertices, and d dot edges dot show will give you all the edges present in the graph. So okay, we have got this information. We have to listen down, and we have got this friend relation. So coming to the page rank, like page rank is yet again algorithm to calculate the centrality measure. So that is much popular from the Google. So here this information is the same like the this IDs or the entities are same like the centrality, like in our earlier case of degree centrality, but these values are different because of the different algorithm. So this is the result you can see. You might be able to get some intuition why these values are much higher, because they have much importance in the network, so that their values are much higher. Coming to the level propagation, so this is a very interesting property from the network part, is that we can find these communities like the people associated closely to each other. So like you can say there's a group of friends that are highly correlated, highly in a close bound with each other. They are much closer, but in comparison to some group of people persons that they are not that much closer to each other. So this information can be obtained. Like I will just tell briefly what this information is telling, what this particular data is telling about. So Rajiv has been assigned a level of something like 16072, and Cynthia and she is also assigned the same level, and again Anjali is also assigned the same level, and Tina also has assigned the same level. So they belong to a close group, so they are highly correlated with each other. They have a close bonding with each other. So in total, we can see we have got 3 communities here representing by 3 different levels. So the persons belonging to the same level belong to the same. This is one of the information that we can obtain from Apache Spark in particular. So from this, keeping time constant in mind, I will not explain much. So that's all from my side first.
Yeah, thank you very much, Vish-Shaki team. It was a very nice demo, and I am sure many of the query from the participant might have been already clear from this presentation. But still, there are many questions posted by participants to me privately as well as in the panel. But many of the initial comments posted to me privately, I have to, because of network connection, I have to disconnect. And if I do not put off, then you please post the comment again in the chat. Okay. So I think this is to all the team members. So I am some of the queries posted by them. Let me put up one by one. So one of the query is like, so it may be answered by Mala, so or any one of you. So how integration is happening between Spark and the Cassandra? This is one I think interesting questions, because Cassandra and Spark, they are two different frameworks. So can one of you answer?
Yeah, so we have this Cassandra database and we have this Spark. So to connect Spark to Cassandra, we have to specify the Cassandra IPs of our database, and we have to give its username and password. Like as you connect in like SQL, normal SQL. So and we have to use like a library for connecting PySpark with Cassandra. So we have those library from the data stakes, and some third-party libraries are there to do the connection. So so you have to specify those connection while creating the Spark context. Which Cassandra cluster you want to connect, and all those credentials. Did that answer your question, sir?
Yeah, I think that is good. So another question is a generic question from Sanjay. Let me just read out. So are you using any disaster recovery site in your Vish-Shaki application? If yes, then what is the replication technology you are using? So I not very clear about this question. What you mean by disaster recovery? But if you mean to say that, see, we are using many distributed nodes in the framework. So if you mean to say that, okay, if one node fails, how to recover? Because some of the framework, this clustering framework, they have their recovery means these false.
Ranbir,
Uh,
Ranbir, is basically we can answer this question by data center. We created the data center, and data center can be any machine. It is in local or it is in disaster site. So basically, data question. We have created our data center, correct?
yes, yes, yes.
So you just mentioned that part.
Yeah, so in this our data center, we have many distributed nodes, and so we have the kind of say failure management component. If one node fails, other node will take care, and we maintain many replications. So at present, we are using 3 replications, but it can be extended depending on the infrastructure and so on. So we are we have this infrastructure. But I have lost all the questions that are posted in the beginning. If other panel members can see that, can you please provide?
1 minute, I am talking about. Go to the question answer. There were some questions. What was that? Linkage? One question was, can you please explain lineage with an example? But that is for Rahul. Can you say something?
Yes, sir. So Linus graph is, so suppose, as I said, like RTD can be converted from one to another. So while converting this one from to another, so suppose, as an example, if I want to convert from string from lowercase letter to uppercase letter, then after converting to uppercase letter, I want to filter out some of the words. So we have this three step-by-step information that we have to perform. First, we have to convert into uppercase letter. Then we have to perform filtration. So Linus in a sense, like this sequence of operation, it remembers. So what should I execute? Is first I will convert into uppercase letter, then I should perform filtration. The main reason for keeping this Linus is, so suppose while converting to in uppercase letter, my database got disconnected, and since it got disconnected, it will fail. The job will fail. This conversion to upper letter. But since we are keeping the Linus, we can retry that execution.
Okay.
So that.
Okay. we have given as an example. Mala, you have one question. In case of YouTube API, will be in which format? One question from Abhay Kumar Pradhan. Is it collecting only metadata or video itself? Crawling data in which format? First question. Second question is, it is metadata or video itself? Mala, are you there? Okay. Tell. Crawling data in which format? That is the first question. YouTube API.
Yeah, maybe let me help here. So we are collecting metadata as well as video. So that we are collecting what the
The format is that just okay. You is in JSON format, correct?
Yeah, this metadata will be provided in JSON format, but image can be collected independently.
Next question is, can we get all comments? That is 100% of the specific video. All comments from YouTube API. So,
yeah, this specific information I think Mala can answer. I don't have that.
okay. You are mute. Mala, you are mute first.
Hello, am I audible, sir?
Yes. Tell
Yes,
the
sir.
comment related to YouTube API, comment 100% we will get or not.
Yes, sir. Sir, we can get all the comments. They will provide all the comments if, because if the comments are publicly seen by means publicly seen by users, then we can get all the comments. If the users have privately blocked them the comment, then we can get the comment. But if it is publicly available, then we can get 100% comments from the YouTube API.
Okay. One question for Rahul. Can we implement sequential algorithm in Spark environment? Will it improve the performance?
Sir, sequential algorithm.
Algorithm
Yes.
in
Yes, sir. Whatever it should be sequential, sir. It should be implemented sequential.
and whatever parallel can be implemented. Correct?
Yeah, sir. Because since so suppose if I have a function that should be executed sequentially, then that parallel in the sense in terms of data. So this function should be applied to all the data. So suppose if I have to apply this function to all the rows. So this function itself is sequential, but the process of applying the function to all the rows can be parallel.
Okay.
This actually under this we have something like MapReduce framework. So when you try to aggregate and compute to individual nodes under the MapReduce framework, so this computation is parallel, but within the node it is sequential. Okay, so that is for the parallel distributions. But if your underlying problem is sequential by itself, then we have to we have to do the sequential execution.
No more public questions to all.
Okay, there is one question for Sanjay, but this is a generic questions. So this regarding the previous this one replication DR problem, a disaster case. So the question is, what will happen if it is earthquake? Okay, so and DR should be in different seismic zone. This is quite fine, but for at this point, the data center is for local data center managed in the lab. But when it
No,
is
wait. This our thing is overlay. Our every operations are overlay network, and if data center is replicated in two different seismic zones, our system will work. But basically, our system is looking into the data centers available and their connectivity and fault tolerance. So irrespective of the lower level data center concepts will continue. Okay.
And one more, okay. One comment is it is written in Hindi, so I'm not
It is
very.
not comment. It is not comment.
Oh, okay, okay, okay. What is?
This
Can you please
Ganesh
start, sir?
Chaturthi. Ganesh Chaturthi today.
Oh, okay, okay, okay. Thank you very much. Thank you very much for your wishing. Okay. So I'm sorry that many of the initial comment I have lost because of the network issue. Okay, and we will be uploading all these materials. So
So
you.
one comment. One comment. One question is P.R. Das that softwares are open source. Yes. Answer is yes.
Yeah, so for those participants who could not attend this session because of the festival, okay, they can so they can access from the resource that we're going to share. So with this, I would like to congratulate the team, and yeah, thanks once again on behalf of all the participants.
All participants, please visit our websites and look into our Vish-Shaki and please comment if you have.
Yeah, your input will also be useful. Thank you very much. So with this session, we have already
We close.
extended half an hour. So we'll wind up and
Wind up.
we'll meet at 2:30.
Yes, sir.
Okay.
It is for a lunch break. We'll meet
Yes.
around.
Okay.
Thank you, Vano. Good afternoon, Nilakshi. Good afternoon, Nilakshi.
Good afternoon, sir. Am I audible?
Yeah. So
Okay.
can you check whether you can upload, share the screen?
Okay, let me check. Yeah, I am able to share the screen. Uh,
Yeah, we can see the screen.
okay.
Just
But I'm
roll the slide. Let's see if it is stuck or rolling.
okay because actually I'm not able to like this thing.
Oh, okay.
It's okay, right?
Yes, it is visible now.
Okay. Yes, sir. Okay. Mm, okay. Okay. Like in which part was the beginning or was the end?
Very good afternoon to all. So now it is 2:30, but since participants are joining, maybe we will wait for 5 minutes and we will start at 3:35. So Nilakshi, shall we start?
Yeah, I think it's 2:35. We can start.
Okay. So all, and welcome to the second session of the fourth day of this training program. So today, Miss Nilakshi Sharma will be taking this lab session. She is one of the graduating research scholar from ISEA Lab, and she has been working on various deep learning models for last many years. And currently, she is doing research internship in Amazon. And so I have requested her, considering her long experience of working in deep learning framework, to take up this session. So today, what we are going to see is something called, learning representation through neural models. So in the previous sessions, when we try to build classifier, what we have seen is like we have to manually find the features, right? So explicit features from the given data set we have to find, and we have seen there are limitations of finding features, say manually, because it depends on the expertise of the user and so on. So this representation can also be learned automatically. That is the idea here. So this representation learning, or representation of the samples automatically, it is not a new research problem. So from the beginning of the machine learning, this approach has been adopted, but the term embedding has not been used earlier. So if we see some of the method that we discussed yesterday, like principal component analysis or SVD, those dimension reduction methods, they are also used for learning representations. Okay, so earlier people have used dimension reduction and so on to learn the representations. Then with the increase in computational resources and popularity of the deep learning framework, people started exploring, learning to represent the samples using the neural models. So today she is going to briefly introduce, some of the neural models, and talk about something called word embedding, which can be used for representing words, then sentences, documents, and so on. So with this brief introduction, I request Nilakshi to start.
Thank you, sir.
I think you have not shared your screen.
Sure. So is my screen visible now?
Yes, yes.
Okay, sure. Thank you. Okay, so in today's lab session, as Sarah said, we'll try to explore some of the neural network-based representation learning methods. But before that, it's important to have an idea about some of the concepts concerning neural networks, so that so that those other representation learning algorithms and other things are understandable. So I'll try to briefly discuss about some basic stuff about neural networks, how to define neural networks, how to train, how to evaluate, and so on. And yeah, let's start it. So yeah, first of all, I'd like to call out that some ideas here has been borrowed from the CS7015 course by Professor Mitesh M. Kapra. So acknowledgements for that. So what is a neural network, right? A neural network is nothing but a network of neurons. Neurons, or we can also call them nodes. So now what are neurons or nodes? Those nodes are nothing but there are some computational units. What they basically do is they take some input, perform some computation, and generate some output. For example, if you look at this neural network shown in this slide here, we see that it receives two input, x1 and x2, performs some computation inputs, and generates some output. Right? So this function f here can be a very simple function, for example, linear function, or for example, it could be a logarithmic function, exponential function, whatever operations we want to perform. So basically, you take input, define the operations you want to perform, and generate some output. That is what a neural, right? So this is a simple network with probably one node in the hidden layer. So we can have larger networks where we have many nodes at the input layer, many nodes at the hidden layer, and many nodes at the output layer. For example, this is one network, for example, where we have 10 nodes at the output layer because we want to predict 10 classes. So we can again have multiple hidden layers as well. This is, for example, a neural network, 2 hidden layers. So we can, so basically, we can like connect multiple nodes together to perform the desired computation, and that becomes our neural network. So to understand some of the basic concepts of this neural network, let us consider some very simple networks and try to understand some basic concepts around the around these networks. Okay, so let us consider a very simple use case. For example, suppose that I want to predict whether a celebrity is popular or not based on his number of followers. So I have an input x1, and I want to perform some operation about this input so that to generate an output, and based on that output, I'll decide whether a celebrity is popular or not, for example. So in this case, for example, I have defined this function, this computation here to be a function. So it takes an input x1, multiplies it with a weight plus the bias, and generates the output. Now the thing is that here the generated output can take any values, right? So how do we predict whether a celebrity is, for example, popular or not? So it's very simple to do here is that we use a thresholding logic. For example, suppose we decide upon a threshold that if the output is less than 10, then we say that the celebrity is not popular. If it is greater than 10, then we say that the celebrity is popular. So this can be a very simple classification approach, but there is an issue with this approach. What is the issue? The issue is that this thresholding logic is very rigid, or it is very harsh. For example, suppose we have decided upon a threshold 10. So if the output is 9.5, we will declare that a celebrity is not popular, and if the output is 10.5, we declare that the celebrity is popular, which kind of does not seem correct, right? It would be perhaps more helpful if we can get some real valued output, for example, some output between 0 to 1, so that we can say that if the output is very close to 0, then we can say that perhaps he is not very popular, and as the output proceeds towards 1, we can say that that is the kind of range of his popularity. Now, how do we achieve this? How do we convert a real valued output to a particular range between 0 to 1? So it turns out that we have a very useful function that we call a sigmoid function, which takes some real valued input and squeezes the value of the input between 0 and 1. For example, here now, if instead of a linear function, we define this function f to be a sigmoid function, then it will take this input w1 x1 plus b and perform the sigmoid operation and yield a value between 0 to 1, which we can use as a score to indicate the popularity of the celebrity. So this sigmoid function here in the neural network literature is known as the activation function. So we actually have many activation functions that are used in neural networks, and the most important purpose of this activation functions is to introduce non-linearity to the output. Because, for example, if we consider in the absence of a sigmoid function, this function f here is a simple linear transformation, which probably will not add a very much value to the network. But if we can apply some non-linear transformations, there are different ranges of spaces that we can visit, and that will probably add more capability to the network. So, such activation function we have other activation functions, for example, 10H, ReLU, that is rectified linear unit, softmax activation function, so on. So you can explore these activation functions. They have their own properties, advantages and disadvantages, and based upon their property, the problem requirements, we can decide which activation function should we use with our neural network. So, so far what we have seen is that we have a network. The network takes inputs. It multiplies the inputs with the biases and applies activation function, and we get some output. This is what we have seen so far in this. That is multiplied with the weights and biases, and we have a function f where we can use any activation function of our choice, and we generate an output. So now the thing is that when we say that a network takes an input, question is that who will provide the input. So basically the end user who is defining the network based upon the problem requirements. For example, if the problem is set of sentiment analysis, perhaps we will provide a set of tweets or product reviews. That will be the input for sentiment analysis. Similarly, based upon the problem, the user will also decide what activation function to use. For example, if I want my output to be between 0 to 1, I can use a sigmoid function. If I want my output to be between -1 to 1, I can use 10H function. So depending upon my problem requirement or the problem choice, I can decide the activation function. Next, we have the weights and biases. Now, who decides the weights and biases? Will the user provide the weights and biases? So then the neural network actually learns the weights and biases during training, and this is the specialty about neural networks, that it is able to learn the weights and biases on its own, and that's why we say that we do not require any manual feature selection when we are using neural networks. We simply give the input to the neural network, and we give the output, and the neural network will decide upon what weights to assign to which input so that we reach upon the desired output. And that is like the most the most useful feature of neural networks, because of which it is being so popularly used nowadays in almost every problem domain. So the steps to decide the values of the weights, what values of weights and biases should take, that is nothing but the training of a neural network. So it is during the training phase that we try to learn appropriate weights and biases for our neural network. So basically now, if you want to train a neural network, we require 3 steps. First step, we need to define a training set. So we need to define that this is my input, and these are my output corresponding to this input. For example, if I have an input x1, then my corresponding output should be y1, for example. Then we should define a loss function. What is the loss function? The loss function will indicate how much the output of the neural network deviates from the given input. Right? For example, given an input x1, the neural network should output in value 0, but it is actually outputting a value 0.5 or perhaps 1.0. So to measure like how much the actual output is deviating from the expected output, we need to define a loss function. So there are different loss functions that are defined in neural network architectures, and depending upon the problem space, we can decide what loss function to use. And once we have the training data, once we have defined the loss functions, then we tune the weights and biases so that the loss is minimized for the neural network. Okay, so let us, for example, consider this simple example. Suppose I am given a set of text, and I want to assign sentiment level to this text. For example, if 0 means neutral, 5 means positive, and for example, I want to assign values between 0 to 5, right? what I feed to my neural network is I will feed that these are my x's, that is these are my inputs, these are my y's, that is these are my outputs, and now you decide what should be the appropriate value of W1, W2, W3, and B, such that given any of this input, I get the correct output, right? So, so here, as you see in this example, we have these inputs connected with the weight. We have defined the loss function. So this loss function is the square the actual value, and that is the expected value, and what we have actually obtained. Based on this loss, we will try to tune the values of W1, W2, and W3 so that we get appropriate output for each corresponding input. That is what the training process is all about. Given input and output, how do you learn the appropriate values for all the weights and biases? So now the thing is that how to decide these weights and biases. One probably option is that you randomly search an entire space, you randomly search for values and select those set of values that gives the minimum loss. So for these small examples, it might seem feasible, but in the real world scenario, it is not feasible when we have to deal with large number of networks. That is definitely not one of the feasible option. So it turns out that we actually have a principled approach to determine the weights and biases, and that is given by something called the gradient descent algorithm. So what this descent says is that if we have a multivariate function f, which is defined and differentiable in a neighborhood of a point A, then this function fx decreases fastest if one goes from A in the direction of the negative gradient of A. So if we consider our loss function of fx, what is our objective? Our objective is that for any given input, we want to minimize the loss function. So in order to minimize the loss function, what should we do? We should follow the direction opposite to the opposite to the gradient. That is, we should follow the direction of the negative gradient. Networks learns these values for weights and biases is it starts with some random value, and then it iterates over many iterations, and in each iteration it tries to follow the direction opposite to the gradient of the function. For example, suppose we have two inputs, W0 and B0. What we do is that we'll randomly initialize W0 and B0, and at each time step, we will follow a small distance in the direction opposite to the gradient. So here sorry for the notations, this t plus 1 should have been prefixes. Anyway, so we have Wt plus 1 equals to Wt minus n and gradient of Wt. So what basically it says that when we have to take a step from time step t to time step t plus 1, we will move in the direction opposite to the gradient, but we do not want to take a very large step. So that's why we have this factor n here, which is generally a very small real number, perhaps in the range of 0.001 or so. So the objective is that we should not make a very big jump. We should make very tiny steps. Why? Because if we make it very big, we might overshoot the minimum, because the objective here is to minimize the loss function, right? But a very big jump, we perhaps will take a jump from one suboptimal point to another suboptimal point, and the optimal minimum point would perhaps be somewhere in the middle, and we overshoot that. So that's why we use this factor n as this n is for the learning, and the objective of the learning rate is to ensure that while we are traversing the search space, while we're searching for the create values for weights and biases. We are not making very big jumps. We are making very tiny steps so that we do not jump a minimal point. So this is what the gradient this is all about. And so we can starting with some random value, we run this algorithm either some fixed number of iterations or until the loss has reached some minimum value, or suppose that there is no change in subsequent iterations. So there can be different criteria to decide on the number of iterations or when should we stop. But this is basically the algorithm that we follow. Start with a random value and then follow the direction opposite to the gradient. Right? So now for illustration, let us consider a very thin neural network so that it is easy for understand how these weights are organized. So we have one input node, one hidden node, and one output node, and we have the parameters W1 and W2 between the input and hidden and output. So we have so we start with some random value of W1 and W2, and we compute L, which is the square difference between Y1 and Y. So Y1 here is what we have computed, and Y is the actual output value that we expect for this given input X1. So once we compute the loss, if the loss is 0, well and good. If not, we want to minimize the loss. How are we going to minimize the loss? By tuning the values of W1 and W2. How? Of W1 and W2 for each, we will follow the direction of the negative gradient. So what will give us the gradient? Basically, the derivative of the function at that particular point will give us the gradient. Now, I have used this. I have used this very thin network to so that illustration is easier. So here, basically, we have only one parameter. But if we look in actual cases, we have multiple parameters, because we have multiple input nodes, multiple hidden nodes. So when we have multiple parameters and we want to find the gradient of a function with respect to a parameter, we will basically do a partial derivation. So that's why I've used the partial derivatives symbol here. So basically, so once we have once we compute the value of L, we will change the value W2 by moving in the negative direction of the gradient, and we'll also change the value of W1 by moving in the negative direction of the gradient. Now, one thing here is that now L is directly dependent upon W2, so we can directly find the derivative of L with respect to W2. But if we see here, W1 is actually not directly L is not directly directly dependent on W1. It is L is dependent on W1 via H1. So in order to compute the derivative of L with respect to W1, we will use the chain rule. That is, we'll have partial derivative of L with respect to partial derivative of H1 multiplied by the partial derivative of X1 by partial derivative of W1. So this is how we will adjust the weights and biases. So this is for the simplicity of illustration, I have used a very thin network. So when you can have deeper networks, we can have wider networks, but these are the steps that we will follow. We'll have a so we'll have some randomly initialized values of the parameters based on which we'll compute the loss. That is called the we call that the forward propagation. And once the loss is computed, we again compute the we again change the values of the parameters, and that is called the backward propagation. Basically, the name backward propagation because we start computing the values from the output layer and propagate those values towards the inner layers, because basically the output layer is dependent on the input layers via the hidden layers. So that's why the name backpropagation. So basically, if you see this gradient descent combined with backpropagation is everything contains everything that the neural network does. So also all this advantages of neural networks that we have, that we do not need explicit feature selection. We do not need, we can just give the inputs and get the outputs. So this is all achieved via this backpropagation algorithm. So basically, to summarize, if we have a neural networks, we define the inputs, we initialize weights and biases randomly, we define activation functions according to our problem space, we define loss functions according to our problem space, and then we tune the weights and biases using backpropagation such that the loss is minimized. So we have different neural network architectures. The ones that I have discussed now are simple, are known as feed-forward neural networks, because we have connections in only one direction, and we have fully connected layers. So these are generally called as feed-forward neural network. Then also our multi-layer perceptron. Then we also have other commonly used architectures like convolutional neural networks, recurrent neural networks, long-term memory networks. So all these networks basically architectures differ on how the layers or the different nodes are connected to each other. At the end, these are all connections of these are all nodes connected to each other via some weights and biases. The way in which they are connected, these connections define the different architectures. For example, in recurrent neural networks, I'm not sure, probably we'll discuss them tomorrow. We'll see that we have a connection from an input from a hidden layer to itself. So based on the type of connections that we have, based on the type of layers that we define, we have different neural networks architectures. So we'll not go into the details of this neural network architectures today. Basically, today we'll try to discuss one application of a feed-forward neural network, that is in learning word embeddings. So what are word embeddings? Word embeddings are basically dense vector representations of words such that similar words lie close together in the vector space. So before going to dense vector representations, let us first try to understand what are the disadvantages of these first representations. So prior to these word embedding methods, words or vocabulary were basically represented by one-hot vectors, where the vector size corresponds to the number of words in the vocabulary, and the value at the position corresponding to the word is 1, and all other words is 0. For example, suppose we have, for illustration, we consider that we have a vocabulary of only size 4. Then each of these words are defined by a vector of size 4, such that the value corresponding to that word is 1 and all other words are 0. Now, some of the disadvantages here is that these vector sizes grow rapidly with the size of the vocabulary. So in real world, we won't have vocabulary sizes of in tens or hundreds. We'll have vocabulary sizes in billions and billions. So if we have to represent these words in such a big space using word embedding vector or using sparse vectors or one-hot encoding vectors, that is going to be very, very expensive. For example, each of the words will be represented by a vector of size, say 1 million, but perhaps it will not contain much information, because for example, suppose we want to find the cosine similarity between cat and dog. So if we find the cosine similarity between cat and dog, basically we'll do the dot product operation and we'll find that the cosine similarity is 0. Similarly, between any two words, the cosine similarity will always be 0 if the words are represented by one-hot and encoded vectors. But perhaps it would be useful for us if we can have some representations that also capture some notion of similarity. For example, we probably want the word vectors to be such that the word vector representation of cat is similar to word vector representation of dog, considering that both are animals. Or similarly, probably we would like to have the word vector representation of man similar to word vector representation of woman, and so on. So that is basically the idea behind word embeddings: how to represent words in a compact space, in a small space, in a small sized vector, and how to make those vectors meaningful. How can we make them capture some meaningful information, for example, similarity information or any such information? So some of the methods that we have seen yesterday, for example, ISEA or LSI, can also be regarded as word embedding methods, in that the words are represented in a reduced space. So those word embedding methods are basically based on matrix factorization. Today we will see how word embeddings using neural networks. So we have something called the word2vec. So word2vec is actually a collection of algorithms. It in itself is not an algorithm, but it's basically a collection of two different algorithms. One is called the continuous bag of words, and the other is called the skip-them model. So both the models are very similar with very minor differences. We'll talk about that later. But basically, what these models do is that they use neural networks to learn associations between words, such that similar words lie. So basically, what they do is that they generate a vector space such that each word has a unique representation in the vector space, and similar words should lie closer in the vector space than dissimilar words. That is the objective of these models. Basically, these models are two-layer neural networks, in that we have an input layer, we have a hidden layer, and we have an output layer. So let us first talk about continuous bag of words model. In the continuous bag of words model, what we do is that we provide the words in the context, and we try to predict the words in the we try to predict. For example, suppose we have this sentence in our purpose: the man sat on the chair. Now, what the neural network tries to do is that, for example, for the word the, given the word the, it tries to predict. So, for example, consider the word man. So, for the word man, this word the is a context word. So, the objective is that when we give the context word, can we predict the target word? So we'll see that training the neural networks in this manner actually solves both our objectives. One is obtaining dense representations, and secondly, obtaining representations that capture the notion of similarity. So basically, this is the continuous bag of words model, where we have an input layer, we have a hidden layer, and we have an output layer. So the size of the input layer is equal to the vocabulary size. So this and the inputs are represented in the form of one-hot vectors. So once we feed these input words in the one-hot vectors, they are projected into a hidden dimension, and then we try to predict the output. So what do we want to predict at the output? At the output, we want to predict given the context word, at the output, we want to predict the target word. So, for example, given the word, the, Also, given the word the, when the input is the word the, at the output, we would like to have the word man. So basically, what they do is that they have the input is represented as the one-hot encoding, and the output is represented as the probability distribution of all words. So the input is of size. The size of the input is equal to the size of the vocabulary. The size of the output layer is equal to the size of the vocabulary, and each node in the output layer corresponds to the probability of the output probability corresponding to that word. For example, suppose when we give that as an input, we would expect that at the output layer the probability of the word man should be close to 1. That is the value at the node corresponding to the word man should be close to 1, and all other probability values at all other nodes should be close to 0. So to define the loss function, we have something called the cross entropy loss. Basically, what the cross entropy loss tries to do is that it tries to it tries to compute the expected probability with respect to the actual probability. So the cross entropy loss will be minimum when the probability corresponding to the target word is 1 and the probability corresponding to all other words are 0. If the probability corresponding to the target word is not 1, then we'll have a higher cross entropy loss. So basically, if the target probability distribution is close to our if the predicted probability distribution is close to our actual probability distribution, we have a very low cross entropy loss, and otherwise we'll have a high cross entropy loss. So basically, we have the input, we have the output, and we have the loss function that is defined by the cross entropy loss. So we once we have defined the inputs and the outputs, we can train the network using backpropagation like we have seen in the earlier cases. So based on the value of the weights, based on the value of the loss, the weights will be adjusted, and we'll do that for some fixed number of iterations or until the loss converges. So once the training procedure is over, this matrix at the input side, that contains the weights between the input layer and the hidden layer, is regarded as the word embeddings. So the question is, why is it regarded as word embeddings? So if we see carefully, what the operation is, so if this is our if our input is x and our and the weight matrix is w, so basically what we the computation that we perform there is wx. So we see that when we multiply the weight matrix by other one-hot encoding factor of the input word, then the column corresponding to the input word is activated, right? For example, suppose that we have 3 words and we have and this second element is activated. So we find that the result of this operation is actually the second column. So we can say that there is actually a one-to-one correspondence between the input words and the columns of the weight matrix. So that's why we can regard this matrix here at the input side as the resultant word embedding vectors. So these vectors will be of size d, that is the size that we have, that is the size of the hidden layer, and that is the size of the hidden layer. And we actually, it has been found that this embeddings that are obtained by training the network in this manner are actually very very informative, in that they actually the first thing is that they are very dense. we have they're reduced in size. So for example, V, which in real scenario is in the size perhaps in the size of millions, is reduced to size of say 100 or 200. And second, this vectors also capture the notion of similarity. That is, similar words always have similar representations. So the why similar words will end up having similar representations, the theoretical proof is not there, but intuitionally we can justify, because what we are trying to do is that for each target word we are trying to predict the context word. So in doing that, for words in the that occur in the same context, we are trying to adjust the weights for the same target words. So in that manner, we actually end up having similar vector representations for words that occur in similar context. So ultimately, what we have is that we have similar vector representations for similar words. So this is both the skipgram and the continuous bag of words models are very similar. They are only difference is in the objective. So in the continuous bag of words model, we give the words in the context as input, and we want to predict the target word. Whereas in the skipgram model, we give the target word as the input, and we want to predict the words in the context. The neural network architecture is basically similar. We have in both the cases we have the input layer as the one-hot encoding of the words, and we have the output layer as the probability over all words in the vocabulary. But yeah, one thing I'd like to mention, this training is very expensive because word embeddings are generally trained over very large corpus in the range of millions, and that is very time consuming. So generally there are different optimal methods that have been like discussed in literature, and that are also used in practice for reducing the cost of training. For example, the softmax layer is replaced by something called the hierarchical softmax. We'll not be covering those details, but just mention it here for reference, so that if anybody is interested, they can go and look into those literatures. So I think with this brief understanding of neural networks and brief understanding of word embeddings, we can move towards the session where we will try to build some basic neural networks and try to use the try to see how to feed the input and how to generate the output. So generally, as we have seen that we have different steps in training a neural network. Like we define the weights and biases, we learn the weights using gradient descent backpropagation. So generally, we do not do all of that from scratch. There are some deep learning APIs and libraries that provide a lot of these functionalities wrapped into specific functions and modules. So like we have seen in the previous sessions also, for example, where you have trained classification models using SVM or naive-Bayes algorithms, you do not implement them from scratch, you import the modules from the libraries. Similarly, for deep learning, also we have, or neural network in general, we have different libraries that are available: Keras, TensorFlow, PyTorch, Chainer. Today we will look into, today we'll try to use the Keras library to see basic, how we can define a basic neural network, how we can feed the input, train a network, and see the output. And then we'll also try to see how we can obtain word embeddings using some of the available tools, and how we can use this word embeddings. Should I proceed towards the codes? Are there any questions?
Yeah, I think you can start the code.
Yes, sir. Just take some time because it's connecting. Okay. So first, let us see how we basically, I think in the last 2 lab sessions we have been exploring a sentiment analysis dataset where we have tweets and the corresponding sentiment levels, and we try to predict the labels for the tweets. So today also we'll try to do the same thing, but instead of using the traditional neural networks, we'll try to use some, instead of using the traditional algorithms, we'll try to use some neural networks. So, so I think you already have the data set with you where we have the, tweets. In each line we have the tweet tab separated and then the corresponding level. So this is the file that I'm loading here, and so we open the file, and so this is just simple to open the file, read the file, and so on. And then we define some simple functions.
Your screen is not visible.
Okay, let me stop sharing and try to reshare. It's already shared. I'm not sure why it's not visible.
Are you sharing screen or?
I have stopped now. Let me try sharing again.
We can see now.
Okay, sure. Okay, so basically, same file that you have been using where we have the tweets and the labels. So I opened the file with the input file. Now try to do some. Let us not spend very much time here. So this is where some basic pre-processing. For example, you try to remove the URLs. You try to remove some symbols. You try to remove some stop words. Skip that one. So once we have the input, what we want to do is that we want to divide it into a train set, test set. So, what we do is that we randomly shuffle the entire data, and suppose we will split it into a size of 80-20, such that we consider 80% as the training set and 20% is the test set. So that's basically what we are doing here. We are shuffling the data and we are dividing it into 80 and 80% training and 10% test data. So after that, so now all this data is in string format, and we obviously cannot fit this data in the string format. So we will convert these strings into some unique IDs. So each words in the vocabulary will be represented by ID, so that each sentence or each tweet can be represented as a sequence of, as a vector of integers. So basically, so that's what we are trying to do here. We read the input lines, perform the basic reprocessing like removing symbols and all, and we load the entire vocabulary. Once we have loaded the entire vocabulary, we try to assign a unique ID to each word. So basically that's what we are trying to do. We are doing in this portion where we have so our entire vocabulary is stored in this list vocab, and then we are loading it into a dictionary where the key is the word and the value is the corresponding ID. And we also have the maximum length information that we'll use later on. So in your previous sessions, what you've perhaps done is
Lakshi,
sir?
yeah, sorry to disturb.
Yeah, sure.
So, can you check with the participant if they are able to say load this program from the GitHub?
Okay.
If they can follow the step that you are executing here.
Okay.
So, dear participant, can you please confirm if you can, if you are able to download the program from the GitHub? I think it is here in the chat box, and that GitHub link. And if you are able to download and run this, open this file and execute in parallel. Some of them have downloaded. Maybe we'll just see how many of them. So please share your comment in the public, okay? Not to my this one personal private, so that other panelists also can see.
We have shared the GitHub link. Gyanendra, you have shared the GitHub link, right? Gyanendra, are you there? We have shared the GitHub link.
Yeah, so I have again shared the GitHub link. So dear participant, can you please confirm if you are able to download and open the file so that you can run the code in parallel to the presenter. Yeah, some of them are able to run, and some of them are facing problem like path issue for the files. I think this is local problem to the participant. So to the participant, you should put that data set in the same directory where you are downloading this program. Okay, the data set file should be in the same directory. So please make sure that the dataset is in the same directory of the source code of this tutorial. Okay?
Right now we are using the sentiment dataset. I'm not sure where you are trying to upload, but yeah, this is a sentiment dataset that we are trying to.
Oh, Nilakshi, in your program,
Mhm.
the program that you have uploaded, what is the part of the this one? You just okay. So this part should be just sentiment. Okay, the part of the file, dataset file. So presenter is accessing from different directory, but in your case, you should put this in the same directory. So without your path should be modified. Nilakshi, your screen. Oh yeah, I think they are, some of them are able to do that. So this deep learning keras, this is the source. Okay, and in the same directory, you should put the dataset.
Yes, the dataset should be in the same directory.
can you please confirm if you are able to open the file, dear participant?
Yeah, I think some participants are trying to download from some other location, so I'm sharing this again. If you want to get the link, please download it from this link.
Nilakshi, maybe we'll wait for 1 or 2 minutes just to make sure that they are able to
Yes,
download
sure.
and set up. Just assist them, okay?
Yes, sure.
Yeah, some of them are able to open, but let us wait for some comments from some participants.
Yes, so we can wait for a few more minutes.
Some question is, can we run directly from the GitHub? I think that is not possible.
That is not possible, but if you're not able to run in your systems, you can try using Google Colab. You can run directly.
But they need to know how to.
Yeah, but yeah.
That will be a long process. So we would probably suggest you to download and run on your local machine. Those who are able to download in the setup, can you please confirm in the chat box? So I think some of them are facing problem, but I think since we will be sharing the code, they may be later on they can I can run. So Nilakshi, maybe I'll request you to resume, and maybe you go a little slowly while explaining the code, so that line by line they can follow up.
Okay, sure. So,
just before starting this, one doubt is how to put the data set in Google Colabs. So, Ganendra, can you please help him? Anamika Moria. Ganendra, you can probably help him.
Yes, sir.
Yeah. Nilakshi, you continue.
Uh,
No. You help him
I-
by comment. Ganendra, help him by writing in the comment box, chat box.
yes.
Uh,
okay, let us try to, okay, so, yeah, so, I think people who are able to download and run it on your systems, you can try running, and if you first find any problem, you can comment in the chat box. So okay, let's start from the beginning. So so first of all, so it is the slide that we are reading. This my location here is different because I'm using Google Colab. You check your location in your files. So you open the file and read the files. This is all right. Then after that, I have defined some functions. These are basically some helper functions to remove unnecessary symbols and text. For example, to remove URLs, links, and any unnecessary symbols apart from alphabets. So probably I'll not go line by line to these functions. These are some helper functions. If you go, if you just have a look on them, you'll be able to understand. Let's proceed to the next session. Okay, so now once we have loaded the data from the file, we want to divide the data into train set and test set. So dividing, we should shuffle it randomly so that we can ensure that the train set and test set are being uniformly sampled. So this is what we are doing here. We have so we have to import this random library, and random test set is basically to set the seed so that next time if you randomly shuffle, you will get the same results. Then you randomly shuffle the lines, and we split the data set into train set and test set. So we will split the data at as 80-20. So that is what we are trying to do here. Determine the number of lines that will compose of the 80% of the data set. And so the 80% of the data set will go in the train lines, and the remaining data will go in the test line. So here. So this is, I think, pretty simple. I think everyone is able to follow till here. So once we have loaded the data and we have divided data into train and test set, next, we now need to convert this So now all this data is in string format, right? And we cannot feed strings into this libraries. They will basically need vectors or integers. So that's what we are trying to do here. What we'll do is that we'll assign a unique ID to each word. So you read all the lines, clean the words, and then create a vocabulary set that comprises of all the words. That's what we are doing here. So this list vocab comprises of all the words in the vocabulary. Once we have all the words in the vocabulary, we'll now assign a unique ID to each word. So that is for that we have defined the dictionary word to ID, and we enumerate over the vocabulary, and we add the vocabulary to this dictionary where the key is the word and I is the corresponding ID. And we start enumerating the vocabulary from 1, so that because you want to keep a special symbol, something we've called the symbol as patch symbol here, so that if we come across some unseen data during the test time, this data also has to be assigned some integer number. So for that we have kept this special token. So this is all that we are doing here. We have obtained an integer ID for each word in the vocabulary. So right now our vocabulary size is 4012 and our maximum sentence length is 9. Till here it is okay. This is only pre-processing. So once we have the ID corresponding to each word, now we will convert the train set and the test set into a list of integers. Currently they are a list of strings, it is list of words, and we'll convert them to the list of integers. So that's what we are doing here. We read the train by line, clean the train set so that any unnecessary symbols are removed. So this file is tab separated. So when we split on tab, the first column is the text, that is a tweet that we have, and the second column is the label. So the class level should be an integer, since it is because it is dumped into a file, we are converted into an integer. Then for all the words in the tweet, we are converting them to a we are converting them to the corresponding integer ID that we have assigned in our previous snippet. So now each of these lines are being converted into a list of integer IDs, and so this is the input. So now the input is represented by a list of integers. How do we represent the output? We will represent the output by a one-hot vector. So for example, so now since we have 2 classes, each of our output will be a vector of size 2. Okay, if our class level is 0, then the value corresponding to the 0th index will be 1, and the value corresponding to the next index will be 0, and similarly for the and vice versa for the distance. So let us try to print some labels so that it's understandable in what format the data is. For example, I'll try to print the first 5. So this is how our the data is. It's in a 2 each class level is represented by a vector of size 2. If the index at which value is 1 determines with that this corresponds to this particular class. So here we have converted the train list of integers and one-hot vectors. Similarly, we'll repeat the same process for the test data as well. The test data will also be in the same format. We'll have the inputs in the form of a list of integers and the outputs in the form of one-hot vector. Okay, so till now we have defined the inputs and the outputs. Now we will define a model. So for we are using Keras model. So it offers inbuilt functionalities that you can directly import. For example, this sequential model, this is a class that is actually defined in a Keras library. You can use to define a model comprising of a linear stack of layers. So when it's a linear stack of layers, for example, suppose you have an input layer, on top of that you have an hidden layer, on top of that you have another hidden layer. So if you want to create such a linear stack of layers, we can use this sequential module. So for that we have to import this module, import sequential. Then we'll also import this dense layer. What is a dense layer? A dense layer is nothing but a fully connected layer. So we have seen in neural networks that we have fully connected layers from, which means that nodes in one layer are fully connected to, all the nodes in one layer are connected to all the nodes in the other layer. So if you want to define such a layer, this dense layer does the thing for us. So we will import the sequential model and we'll use the So once we have imported, we'll initialize a sequential model. So basically we are going to build define a neural network. It is going to consist of multiple layers, one on top of the other, right? So once we have initialized the sequential model, we can keep on adding as many dense layers as you want. For example, I add a dense layer using this function model.add dense. So this is the initializer for the model. So this first input here 50 is the number of nodes that I want this layer to contain. So basically here I am defining that my dense layer should contain 50 nodes, right? And what is this dense layer connected to? So this is the first layer in our network, right? So this is connected to an input layer. So what is the dimension of our input layer? The dimension of the input layer is equal to the maximum sentence layer that we have. So we have generated these sentences all of equal length so that we can process them together. So so if for our particular case, our input dimension is 19. So that is what we define here. So this basically means that we have defined a dense layer that comprises of 15 nodes, and that is connected to an input layer comprising of max length number of nodes. In our case, max length is 19. And activation functions. So as I told, we can use different activation functions. Here I have decided to use the 10H activation function. So basically we have the connections between the dense layer and the input layer, and on top of that we will apply the 10H activation function. So you can try changing to different functions like sigmoid, relu, whatever functions are defined in the Keras library. You can just try replacing this with other and see. So this is my layer that I have declared, and now I declare the output layer. So since I have two classes, I try to treat this as a multi-class classification problem. So I define another dense layer with two nodes. So the first argument here or nodes in that layer. So basically, after this hidden layer of 50 units, I am deciding I am adding another dense layer of 2 units that will act as my output. That will act as my output layer. And here I am using the activation function softmax. So generally, when we are doing classification problems, we try to use softmax activation because that gives us a probability distribution, and it is very easy to interpret those numbers as the probability values for different classes. So here, so basically till this portion, I have defined my network. I have defined that I have a linear stack of layers where I have a hidden layer of 50 units and I have an output layer of 2 units or 2 nodes. And in my hidden layer, my activation function is 10H. In the output layer, the activation function is softmax. So till there, I have only defined the networks, but this network has not been created or no memory and anything has been allocated to this network as yet, right? So for that, I need to compile my model. So for model, so while compiling, I define the different metrics. For example, what is going to be my loss function? What is going to be the metrics on the basis of which I'm going to evaluate my model? And what is going to be my optimizer? Optimizer means So this optimizer here, SGD, stands for stochastic gradient descent. So we are using stochastic gradient descent as an optimizer, which is a slight variation from the gradient descent algorithm that we have discussed. There are other optimizers as well. You can explore the library and try changing the optimizer and see what at all effect it has on the output. So I have defined my optimizer as stochastic gradient descent, loss as categorical cross entropy, and metrics as accuracy. So once I compile this model, so all the layers will be initialized, all the weights and biases will be initialized, and now my model is ready for training. So for training, what we do is we'll call this particular function model.fit, and we'll provide to it the inputs that we have generated, which we have stored in trainx, the outputs that we have generated, which we have stored in train y, then the number of epochs. Number of epochs is how many passes through the training set do I want to have. For example, because the weight initialized in only one iteration through the training set, my weights may not be perfect weights. So how many times do I want to iterate over my entire training set so that my weights are optimized? So that is defined by this epochs. So here we have defined this epochs to be 20. You can check again. You can check. These are all user-defined hyperparameters, so you can try changing them and see if it at all has an effect on the model performance, right? And next is batch size. So when we feed very large networks, it is not possible to load and process the entire network in a single pass. So basically what we do is that we define the training set into batches, and the training set is processed in batches. When we said the training set is processed in batches, we mean that the weights and biases are updated in batches. So we can have, these are all user-defined values, so we can try changing them. So basically, when we train the model, we have the input, the output, the number of iterations that we want to have about the training data, and the batch size. It is in what batch size do you want this training data should be processed. So once we have that, we can run our model. So basically, if you run the model, you'll see that the output for each epoch and output will show the loss. So this loss is nothing but the categorical cross entropy loss that we have met. And this is the accuracy of the model over the training set. So we can see that initially the loss is high and gradually the loss after a certain point, it's not decreasing as much. So this could be due to different reasons. For example, the inputs are not very discriminatory, or or perhaps we need more iterations. So there can be different reasons for that. But basically, what so basically this is the these are the epoch. You can see that as the epoch progresses, the losses decreased to some extent, and as well as we have some improvement in the accuracy. I hope everyone is able to, whoever has downloaded is able to run and see the output for themselves. So this is, we have trained the model. And so there are some other utility functions as well. For example, we have this summary function here, which is show you the summary of the model. For example, here if I say model.summary, it shows that has one hidden layer of 50 units and an output layer of 2 units, and the number of parameters. Epochs is not the number of iterations. So there is. I'm just trying to take one question. There was in question is epoch the number of iterations. So since the Since the training data is processed in batches, so one pass through each batch is one iteration, and when you have completely processed the entire training data for one time, that comprises one epoch. So the number of iterations will always be more than the number of epochs if your batch size is less than the training data size. I hope that clarifies your question. Otherwise, you can put that up again. Yeah. So once I have trained my model, I can evaluate it. So for evaluation, I need the test data. So we already have an inbuilt function that is the function evaluate. The text is input test, the test input and the test output. And based on this, we get the model evaluation. So the result is that we have an accuracy of 63.32% over the test data, and the total loss over the test data is 0.70. This is the cross entropy loss that we have used, right? So this is the overall results that we have seen. That is given by the model.evaluate function. For example, suppose I want to see individual, instead of this overall results, I want to see the prediction for each individual input. So for that, we have this function predict, right? So what this predict function will do, it will take the input and it will give us the predicted output levels. So this predicted will be stored in this. So it will return the predict. We can store in any variable, and then we can try to see. For example, I have tried to here I have tried to show the okay. Sorry, this. Okay, I have not. Let me quickly try to.
Yes, is it test X, Nancy?
Sorry?
Is it test X, test X, test Y?
No, I think, okay. Did I not? No, this is okay because I think that we're running this function. It should be okay. Test X. This is okay. Okay, I think the previous this results were edited. So okay, fine. Okay, so now for example, we have so this predict function will return the predicted outputs for each of the inputs in our test data. And since we have defined our output layer to be with two nodes, so each predicted output will be vector of two values. For example, this is the predicted vector for corresponding to this input. So this is nothing but the probability distribution of the class levels. So this particular input that we have provided, the probability for class 1 is 79%, and the probability for class the probability for class 0 is 79%, and the probability for class 1 is 20%, which seems to be correct because the class level is 0, and we have higher probability for class 0 than for class 1. Right. Similarly, these are the probability value for class 0 and class 1. So here we have a wrong prediction because we have higher probability for class 1 and lower probability for class 0. So these are basically the output probability values. You can also try to convert them into 0-1 vectors, where the index corresponding to the maximum probability will be 1, and the index corresponding to other probabilities will be 0. Otherwise, we can keep the raw values so that we can have a sense of how the probability output probability values are. Till here, I hope it's clear to everyone. If anyone has any doubt, you can ping in your questions. Okay, maybe I'll continue. If there are any questions, I will take in between. So,
okay, just one input here to the participant. So what Nilakshi just shown is, like, as you have seen, we are not explicitly defining the features. That is one. Another is, without embedding, you are as such giving the entire sentence as an input. Okay, so she has not used the embedding. So this is the sentence itself. It has been given as input to the neural models and building the classifier. So is it correct, Nilakshi?
yes, sir, correct. And that's
okay.
Yes.
Yeah. So now you'll be explaining about the embedding and the. Right?
Yeah. Yeah.
Fine.
So as yeah. So right now, what we have, as sir rightly pointed out, we have simple integer inputs which are internally converted into one-hot vectors, and then we have weights and biases randomly initialized. Instead of that, as we also mentioned, as we also discussed during some discuss briefly, it would be useful if we can initialize our models or our input with some meaningful embeddings. How do we obtain the meaningful embeddings? The skip-gram model or the continuous bag of words model is one such option. So, as in practice, if you want, you can try training your own skip-gram or continuous models as well. But we have this particular library called Gensim, which is very useful in which is so what they have done is that they have provided an API to train the word-to-vec model, and this is really optimized so that it is very fast in training. So we will use this Gensim library to generate word embeddings. So essentially, word embeddings should be actually trained over a large data so that the inherent characteristics are properly captured. But for the for the sake of illustration or for the sake of learning, now we will be generating embeddings from a very small file, which is our input file only. But in practice, this embedding should be generated from larger data. So as I pointed out, this is a library that we'll be using for the word embeddings. So these are some essential. So there are some essential modules in the library that we'll be using. As and when I'll mention them. So these are the different modules that you need to import before using the library, right? So now, what I need to give to my EIS input is a list of list of each line represented in the form of list of tokens. So basically, what we do is that we read this file line by line. So let us just for loop here. We are reading this file line by line, and since our file actually consists of 2 columns, we only need the first column for generating. We only need the text input. So from each line, we are extracting the text input, converting them into tokens. That is, this function will convert the string into a list of tokens, and that is that is stored in this variable here that will go as an input to the Gensim module. So once we have converted the entire data into list of tokens, we have this module product dictionary. What it does is that it converts this strings into unique integers. Just like we have converted the strings into unique integers for training our neural networks, here also before training the network, all the strings need to be converted into integers. So we have this, so they have this inbuilt function that does this conversion from strings to integers and stores them in a dictionary. So once I have this dictionary of words and their corresponding IDs, we use this dictionary to convert the data, which was in string format, to a list of to a vector of integers. This converted format will go as input. So here basically we have a class defined as what2vec. So this class will take the text as input. So there are different parameters here which you can try changing. For example, the min count is uses a parameter. For example, if you want to ignore words with certain minimum frequency, you can set this to, for example, you don't want to consider words that are occurring less than 5 times. So you can set min count equal to 5. So all words with frequency less than 5 in the corpus will be ignored. Similarly, there are a lot of other parameters. The important parameters here are the size parameter. The size parameter defines the size of the embeddings. So we have defined the size to be 50, which means that the word embeddings will generated will be of size 50. And and these other parameters you can explore from their documentation. For example, the number of iterations, the number of negative samples, the number of CPU workers, and so on. So once we call this function, initialize this function, what it will do is that it will train a continuous bag of word model or a skip the model. We have this option. I think SG is, you can change this 0 or 1, and 0 is skip and 1 is skip. I'm not very sure. You can check it from the documentation. It might be otherwise. So basically, this segment here will initialize a model, will train the model, and the trained model will be saved in this model variable. So once we have this trained model, one is we can use the model as it is, but second is we can information from the model into text files, so that we can so that next time when you require, we do not need to load the model again. We can with the input from the text files. So here we'll go with the second option. Instead of loading the model again and again, we'll dump the input into text files, right? So basically, this model is nothing but we can initiate. This is an instance of this class that consists of the words and the corresponding embeddings for the words. So what I'll do is that, for example, so you can store whatever format you feel is convenient. How I have done is that I have two files. One is, in one file I'm storing the words, and in the other files I'm storing the corresponding vectors. For example, the vector corresponding to the first word in this file will be in the first line of the vectors file. So that's what I'm doing. I'm iterating over the dictionary, extracting each token, writing it into this words file, and I'm saving the saving the corresponding vector in this list. Next, another file, and we dump these vectors in the same order in this file. So we have two files. One is the words file and the other the vector file, where we have the corresponding words and vectors. If there's any confusion, you can please ping in your confusions. I'm not sure whether this was totally understandable. So if you try to see the okay, so basically, if you try to see in your in whatever folders you are running, you will see that there are two files generated in your folder in the given path. One with the word information and the other with the vector information. Okay. So now we have trained the word-to-vec model using our corpus, and we have done the words and vectors. Now let's try to use them to train our neural networks. There are different ways in which you can use the word embeddings. One is that you can initialize the individual words with the corresponding word embeddings. Since in our case, what we are trying to do is that we are not classifying words, but we are classifying sentences or tweets, right? For each tweet, we are trying to find the corresponding class level. So let us try to obtain sentence embeddings from word embeddings. So how we are defining a sentence embedding here is basically as an average of the word embeddings of all the words in the sentences. So there are different ways in which we can define. For example, instead of averaging, you can concatenate the word embeddings, or you can again train another neural network initialized with the word embeddings to obtain sentence embeddings. Simple. We are simply averaging the word embeddings of all words in the sentence, and we are considering it as sentence embedding. So how we are doing that? Again, I have to define my vectors for input and output. So I am reading my input file line by line. I am extracting the text information and the label information. So now I am initializing an array with array of all zeros of size of the embedding size, right? Why I'm doing this? Because we will now we'll now add the embeddings of all the words, and then finally we will take the average of the average to obtain the sentence embedding. So here, this is what we are doing. So this in text, we have the list of tokens in the sentence. So for each token, if I have an embedding for that token, then I'm adding that embeddings element wise to my total sum. Otherwise, I'm simply adding a array of all zeros. So once we have added up all the word embeddings, we take the average by dividing the sum, element-wise sum, by the total length of the sentence, or the total length of the tokens. So this will give us the average of all the word embeddings in the sentence, and this is now our sentence embedding or our input feature. I hope it's clear till now. So now we have defined our input, that is the sentence embedding obtained by averaging all the word embeddings. Next, similarly, we need to define the class levels. Again, we are defining the class levels as one-hot vectors, like we have seen in our previous case. So, we iterate over the entire training data, and then we obtain our training input and training output. So, for example, just to input. So previously we were having, if you remember, in a previous case, we were just having a list of integers as input. Instead of this list of integers as input, which probably did not have much information, now we have a dense vector representation, that is the sentence embedding corresponding to the input sentence, and these are our outputs. So we have converted the training data. We also need to convert the text data in the similar format. So I'm not going to elaborate this again. This is the same thing that we have repeated for the test data. Once I have the and the test data, now I again define a model. So my model, so again, like I said, we'll initialize a sequential model. Then we'll define the we'll define a hidden layer with the required number of nodes. So now my I've defined hidden layer with 50 units, and my input dimension now is the embedding size. Since we have taken the average over all the word embeddings, so the embedding size of the so each input is of size, embedding is of the same size as the word embedding. So my input dimension is the dimension of the word embedding, and my number of nodes in the hidden unit, and it 10H activation. So you can always try changing this number of nodes and see with increasing number of nodes or decreasing number of nodes how your model performs. Since right now we are doing this over a very small data set, it may not be very like visible, but when we are trying to do it in practice, you can always try to change these parameters and see how the overall model performs. Then this output layer with a softmax activation function, and like we already discussed, we are initializing with our optimizer the loss function and the metrics, and finally we are training our model. So again, for training we have the training input, the training output, the epochs, and the batch size. So and then for each epoch we have the loss as well as the accuracy reported. So we can see again that as training proceeds, our loss is decreasing and our accuracy is increasing, right? So so this is we have seen two cases of neural networks. First is where the neural networks were simply represented by the integer IDs, and which do not carry any meaningful information. And in the second case, we have represented them by the word embeddings. Averaging the word embeddings is one. You can try with other approaches like concatenation or maximum, minimum, and value extraction, and you can see how these different metrics perform. So once we have trained the model, like we have done previously, we can evaluate our model where we feed the test input and the test output. So here we see that our loss, this is the reported loss on the test set, and this is the reported accuracy on the test set, which is 72.4%, right? So this is how we have. So this is how you can use the word embeddings to obtain sentence embeddings and use them for sentence classification. So this is, we have used word embeddings with neural networks, but we can also use them with traditional machine learning algorithms as well, right? For example, in your previous lab sessions, you have used different features, for example, entropy or mutual information. Instead of those features, you can also use these word embeddings as features and see how these different classification models perform. So you already have information about these different models from your previous lab session, I guess. So this are we have just imported different different models corresponding to different classes corresponding to different. Then again, we in here also we define the features as the average of the word embeddings, right? So we follow similar procedure, that is for each line in the training data, we iterate over the tokens, we take their sum, and finally at the end we take their average, and we the training data. One difference is that when we are defining neural networks, our class levels are one-hot vectors, but when in the case of this traditional classification algorithms, for this particular library that we're using, the class levels should be integer values. For example, if we have two classes, you can represent them by class 0, class 1, and similarly. So here we represent each class by the corresponding by a corresponding integer ID, right? So if we try to run, so this is my input corresponding to the first. This is my this is my feature vector corresponding to the first input, and this is the class level corresponding to that. For example, if I try to see class levels, Here, all our class IDs are integer values, whereas in the case of neural networks, we define them as 1/2 encoding. So it was one difference. So in the similar manner, we also again define the test data. Once we define the test data, then you already have explored how to use these functions. So for example, you want to use Gaussian naive-Bayes model. I initialize the Gaussian naive-Bayes model. I train it using my training data. Then we can predict the class levels, and then we can compute the accuracy. Right. Similarly, you can experiment with other others as well. So basically, this exercise was that this word embeddings can be used as, so the word embeddings are nothing but vectors. So these vectors can be used as feature vectors with neural network and networks, as well as non-neural network based classification models. We can simply use them as vectors, use them as feature vectors, and use them to train and test a model. So that's what I have for the for today's lab session. But I think we have some time remaining. So if there are any questions or any confusions, I can take. We can take that.
Yeah, thank you, Nikashi. It was very nice presentation. So I think another participant has asked similar question,
Yes,
that what is the difference between epochs and iteration? So you have already answered. Can you answer again?
Yeah, sure. So iterations is the, so when we okay, before going to iterations and epochs, let us first see how we process our training data. So in practice, we have our training data can be very large. It can be in the range of thousands or millions. So it's possible to, for example, if we want to consider, for example, if we see how we train a neural network, right? We have to compute the weights and biases. So it's not possible to do the computation for large data set at a time. So what we generally do is we divide the data set into batches. For example, suppose if I define my data set as batch size as 200, for example. So the training data is is divided into batches of 200. Now each iteration over those, so each pass over those over one batch is called as one iteration, right? So likewise, when we have iterated through all the batches, for example, suppose if I have suppose 100 training samples and my batch size is 10, so my training data will now be divided into 10 batches. Once I have, so one pass through each batch is called one iteration. So to complete the to process the entire training data, we have to complete 10 iterations. When we have completed 10 iterations, we have completed one pass through the entire training data, and that corresponds to one epoch. I hope that makes it clear.
Yeah. Another question is, I think it might be already clear from the presentation, but still just to repeat it, is it possible to generate weights and biases through machine learning itself? So,
how do I answer that question? So
okay, let me supplement this.
Yeah, sure.
So the idea of machine learning, or say in the back propagation that is being applied in neural model, is to learn this weight and the bias automatically. Okay, so this mod, yeah. So now you can generate. Basically, it's not generation. It's a kind of learning the weights. Okay, it's like you are estimating the weights and biases. So answer is yes. So maybe another question just pop up is, what is appropriate size of bets, and what are the factors that determines that?
So appropriate size of batch, as in we cannot say that what is an appropriate size of batch. So the thing is that, for example, larger the batch, for example, suppose my batch size is 100. So I am updating my weights and biases after I have after I have computed the weights and biases for this 100 samples. So lesser batch size means the weights and biases are tuned more properly, and larger batch size means there might be some there is more averaging occurring. There might be some inaccuracies in the weights and biases, but again, smaller batch size will take longer time to train, and bigger batch size will take will take time to train. So it is basically a trade-off, like depending upon your data and depending upon the time that you have to train the data, accordingly you have to divide the batch size. But probably we do not want to use too large a batch size. Probably 256 or 300 batch sizes is what I have seen. I haven't seen, but maybe when people are training larger data in the scale of millions, they might be using larger bases. I'm not sure, but it's basically a trade-off between the granularity at which the weights and biases are learned and the training and your training time. So depending upon the data and depending upon the other requirements, you have to accordingly decide the batch size.
Yeah, one more interesting question. What is verification loss and accuracy while training a model?
So okay. I think it is validation loss that he's talking about. So when we are training the data, we can set aside a portion of the training data as the validation data. Basically, what it will do is that, so when you are training the data, you are optimizing your weights and biases so that your training loss is minimized. But in doing so, sometimes what happens is your weights and biases might be too particular to the training data and may not generalize over unseen test data. So this validation loss can be used as a check to see that you're not overfitting overfitting on your training data, that your model. So basically, the validation loss will tell you that once you have what loss will your model yield when you use this model to obtain predictions over some unseen data. Can we show word embedding graphically? Yes, you can show, but the thing is that generally the word embeddings that we use is that we use are of higher dimensions, for example 50, 100 or 150. It is not possible to visualize 150 dimensions, but what you can do is that you can reduce the dimensions using different dimension reduction techniques. For example, some of the techniques that we discussed yesterday, like ECD, ECA, and SPD, and you can visualize the word embeddings over the reduced dimension. For example, in a two-dimensional space, that may not give you the exact picture, but given these dimensionality reduction techniques are very good at capturing the important features, it will give you more or less a substantial idea about your embeddings. So yes, you can visualize if you project it in a lower dimension. Are there any more questions?
No, one more.
Yes, sir.
The batch size also depends on memory available in the processors, correct?
Oh yeah, exactly. So I forgot.
We
I
have
forgot
not mentioned that part.
Yes, it is one of the important requirements actually. Like batch size also depends on the available memory. Like we may not be able to load very large data at a time. So depending upon the memory availability, we might have to reduce the batch sizes. Yeah, thanks sir for pointing that out. I actually forgot that.
One more question is the splitting of data in test data and training data 80% or and 20%.
No,
If
that's not.
not, then how we can know this splitting criteria?
So basically, the recommended criteria, I think, is like I think what is recommended in practice is we do cross validation. For example, whatever, for example, if we divide our data into like five batches or 10 batches, and at each for example, suppose what we can do is that we can split our data into sorry, let me gather my words properly. Okay, so splitting criteria as such, I think it's difficult to generalize, but given that if we have sufficient time, I think cross validation is what is recommended, in which you divide the data equally into some X parts, and each session and during each training you use you set aside one part as a test set and use the remaining parts as a training set. So so when you're so ultimately we'll end up training over different you will end up testing over different test sets. I think scores are pretty much reliable because you have verified your model across different test sets.
Yeah, I think one more interesting question. Okay, this is interesting. Is there any existing model which is very difficult to train? Lucky if you can answer this.
Yeah, difficult to train. So I'm not sure how to answer that. Difficult in terms of so difficulty can be in different levels, right? Difficulty in terms of some models require very large memory or processing requirements. Yes, definitely there are many models with huge processing requirements. It is very difficult to train those models. Then what other difficulties?
I think he probably might mean to say some complex model. So just to supplement to Nilakshi, so what she projected is maybe the very fundamental model, the first simplest neural model. So now, depending on the different applications, say different models has been developed, like autoencoder, sequence to sequence model. Then in image, you may have many hierarchical complex network and so on. So, so now much advanced model has, in state of art, there are many advanced models, but what she covered is just a kind of building blocks, like the first step towards the neural models. Okay, so much advanced complex models are there that I think that won't be possible to discuss in this course, but this will give a kind of initial understanding of building those blocks, those models. Yeah, I think. Yeah, I think that must is okay. This question from others. Okay. Okay, so if are there any new questions? Let me just check once. Okay, I think there are a few questions. Few more questions. Let us see if we can pick up.
Okay.
Okay, you can conclude. There's no more questions.
There was one question that this one. Okay, I think it is already answered, I think. Fine. So, Nilakshi, thank you very much for your detailed presentations. And yeah, tomorrow in the lab session, Nilakshi will continue tomorrow's lab session as well. So in tomorrow's models, we'll try to pick up other neural models like RNN, LSTM, convolutional neural networks, and so on. So these models work in different manner, and they are so these different models are suitable for different applications. So idea of covering these multiple models, visualize for what kind of problem, which model should be chosen and so on. So with this input, on behalf of the participant, let me thank Nilakshi for the nice and detailed presentation tutorial. Thank you, Nilakshi.
Yeah, thank you, sir. Thank you so much.
Tomorrow, Ranbir, tomorrow.
So, sir, tomorrow we have 2 sessions in the morning, in the afternoon, and after the lab, we'll try to have a very short panel discussions. Just in case if participants are having some questions related to earlier presentation from different speakers, and if they want to ask some open questions, so we'll plan a very short panel presentation after the lab session.
Okay.
So then see you all tomorrow. Thank you for your time and patience.
Thank you,
Naresh
sir.
will talk now.
Yes, sir.
Okay.
Very good. Thank you.